Testing, testing, 1, 2, 3. Cool. Just waiting for the loop back. Trying to monitor the audio so I can make sure it comes through clearly and stays clearly. So getting used to hearing a repeat, an echo, but it's helpful, so I know if you guys are still hearing me. Sometimes you get glitches in the stream. So anyway, hope you guys had a chance to check out my little test stream from Yosemite over the weekend. It's fairly successful. Still working out some kinks with some optical issues. I need to get some tube extenders. I need to play with some various settings where I'm getting vignetting on the eyepiece projection stuff. It's kind of an older style of photography that not many people are using anymore, but it's valid if you dial in all the settings correctly. Since I'm kind of new at this astrophotography with proper equipment and not just a camera or something, it's figuring out some of these little details are necessary. But there's a bunch of other stuff. I have some other accessories coming, so there are a bunch of other things you can do, like prime focus with a Barlow lens and no other optics in the way, so you actually get more of a pure image, unadulterated by extra optics like an eyepiece and other stuff. So it's kind of nice when you have the stuff like it's the quality of the optics, you know. So if I'm not maybe using the best eyepieces I could get, and that's going to definitely affect the image. So anyway, so let's get on with the goodies here. I have a quick little agenda of going to go over some astronomy apps. They're both for iPhone and iPad, but since a lot of people don't have iPads and a lot of people don't maybe take them out very much because they're worried about breaking them, and because generally if you have an iPhone or it's the equivalent apps on an Android phone, you're basically going to have your phone everywhere you go. So it's nice to have these tools to continue to learn them, see what's going on in the sky, get more familiar with the stars and the constellations and where to find the planets, how to find the planets, all the other typical stuff. And then anything else to do with, you know, much more advanced astronomy, astrophysics, galaxy clusters, all that kind of stuff. You know, there's all kinds of things you can do. With the apps, is pretty. You'll see, it's pretty phenomenal. And this is just a quick survey. I'm not going to go over like every app that I like, but so you get the idea pretty much. No one in the chat yet, so we'll just put a note in there so people know I'm alive and not just a voice on the box. Okay, so let's go on to my agenda and get into the apps. So iPhone, this is a iPhone 14 Pro Max, so it has the multiple lenses on the camera. I even put a fancy case on here so you can do wireless charging. It has like a little magnet in here, and you can hook it to these little magnet batteries. So for long use in the field, you buy a little magnet mount battery that charges it, and I got this little protective case too, so it also protects your lenses on the go. But really cool, so you never run out of juice in the field, especially if you're taking exposures and stuff like I'll show you later. But so that's the device. Pretty good size screen, very clear, nice screen, very fast. And so let me go ahead and start with the first kind of apps I'm thinking of here. So basic tools. One of the things I discovered is you get your basic iPhone lock screen, which is just a, you know, kind of a, what they think is a fancy graphic. It's kind of annoying because the top of the screen was kind of white, and I need to see my with the tethering stuff I'm doing, and in general I just want to make sure the phone is working. I need to be able to see my bars for my signal for the 5G. First of all, is it working, and how many bars do I get? Because I discovered that 2 bars and up, my stream is fine on YouTube. Anything below that, it will try to start, but it won't. I can tether the computer, it will try to start, it won't actually go. So with this kind of luck of the draw, kind of poking through the settings in there, I was going to add another screen to make it darker, and I go, oh, look at this. They actually have a live Earth image in here. Let me fix the brightness here because some of the apps show up too bright on this dumb web camera. So here's the splash screen you can add, and it gives you not only a nice view of the Earth at night in the 3D globe, but it shows you my little location. So you see the little swirls of cloud cover on there. I have the thing turned off pretty quickly here, so. But I can quickly glance at this, and it's mapping live cloud data. So at a glance, without having to go to another app or go watch the news or go to some other website, or I know if I have clouds outside, don't waste time going to set up a scope. I don't have to even look outside. I can just look at the app, and it gives me pretty basic up front. Yes, the sky looks pretty good. And then once you open that thing, it stays in the background as a cool, like 3D globe at a different angle behind your apps. Now I have to actually turn down the brightness because the apps get all washed out. Anyway, so that's kind of a fun thing because I didn't have to install anything. I just had to go in and change a few settings on the phone that came from Apple to have that feature, and it's telling me it's a useful tool. It looks fun because it's 3D globe. You can not that you won't remember where you are, but it does show you where you are on it. Which also reminds you that your location service is enabled, because some of these apps, if you don't enable location services, at least for privacy settings, enable it while you're using the app is the smart way, so it's not always tracking you. And that way, since that's working, you know your location services is on, and the apps that are going to use a GPS function and give you more information that you need is ready to go. So it's another indicator you've turned some stuff on that you need, which is good. So let me go ahead and start with a couple real basic ones here. It's nice to know information that's going on as you're learning the stuff, as you're kind of getting curious about the tools and stuff. So there's one called Astronomy Daily, and it gives you some basic news on events in the heavens. It also gives you some other basic stuff, like this is one on the phases of Venus, which I actually captured a little bit of Venus in my last stream. Didn't turn out that great, but it was okay. Some stuff on Saturn, other various topics along the way. So it's a visual thing that's also a news-based app, which is pretty cool. I've only used it a few times, but I'm pretty sure it's free. I don't think I paid for this one. But a lot of these things, when you hit the get, it always shows the little indicator that it's going to have buy-in options, like after purchase features if you want to enhance the tool and make it better. But a lot of these right out of the box, they're free, and you can do quite a bit of stuff with them without having to pay a lot of money for them. Although a couple of the apps I did upgrade quite a bit, because you get cool things like telescope control and huge databases of objects and all that stuff. That's important to me, but not important to most of you, who are just going to mostly use this stuff for GWiz kind of stuff, which is just perfectly fine. I like GWiz as well. So that's that tool. The other one is called Astronomy News, and again, I haven't used these extensively, but just found ones that were easy to install, gave some information up front. So this one here, this is more matter of fact. Turn this down, it's still too damn bright. And it's just giving you headlines. So this stuff here on news about India landing on the moon and all kinds of other stuff. So this one does have some ads at the bottom, as you can see, so it may bug you once in a while. It hasn't bothered me yet, but I'm always leery of apps that have this, because they make it app free by being ad sponsored. So occasionally I may have to hit close an ad, but it's it's free, so what are you gonna do? Another one is called APOD, which has been around for a long time. It's Astronomy Photo of the Day or Picture of the Day. And there are a bunch of apps that pull from the APOD database, website, online cache. And so, for example, here's today's APOD. Star formation. Is that too bright? That's actually okay. So they give you a nice picture. They give you some facts about the image, who took it, what's special about the object. You can even go full screen and zoom in and see the beautiful image that somebody took a lot of time to get. That's a very nice image. So that's APOD, Astronomy Photo of the Day. What's another one here? Oh, of course, you got to have this tool. Sorry, I have a lot of apps open. I have to scroll through them real quick. You got to have the NASA app. And I'm on the planets page right now. So you can go in and basically, go to the one you choose. There's a little section on Mercury, and it's going to give you some facts and some extra images and some animations. Here's an actual live 3D Mercury in orbit that you can play with, and actually get quite a bit of detail on it, zooming in on it. So this app already gives you some stuff that some other apps give you, and that's all they give you, whereas this one gives you a lot of other cool stuff that NASA's working on as well as an interactive tool. Which reminds me, you actually have, sorry, that's light reflecting is kind of annoying. Let me put a tile behind that so it's an angle. That NASA actually has a huge series of 3D, basically simulations, walkthroughs. You can actually pretend that you're kind of flying over different planets and moons in our solar system. And I forgot to go get that link. Let me see if I can find it real quick. It's been a while since I looked at it, but it's it's really worth it. Just do a, I think it's called NASA Solar System Walk or something like that. Bear with me here while I look for it. There's the web page here. I'm not sharing the web page. I'm just looking at it real quick here, trying to find the quick links. I think no, that's not it. When I finish the stream, I'll put it in the show notes on the YouTube details on the show, because it is something worth checking out. I totally forgot to look at that before I started this. So some of my friends work at NASA Ames, and they, I believe they've contributed to that to a certain extent. One of my friends is basically running some of the, or is not running it, but is a major part of the some of the probe programs that went out not too long ago, like L-Cross, which is it's a kind of a cool thing where they actually rammed into the moon with a probe at one of the poles where they thought they might find some frozen water under the lunar dust and rocks and stuff. And because you can make water from lunar rocks, there's enough elements there to make it technically, but anything you can do to save energy and time and resources and not have to bring water and not have to make water, if you can find it locally and somehow extract it without too much effort, like you would do at Mars. There's actually frozen water under the frozen carbon dioxide poles, and so if going to Mars they could find water there as well. But they I think it's frozen. I better double check that. I think Mars is cold enough to have the frozen carbon dioxide poles, but I have to double check. Sorry, it's been a while since I studied Mars, but they definitely did find water at the poles on Mars just from the analysis they've done. Because you can do, like they do with a lot of planetary science, the places we haven't directly been to, just like they can do measurements of stars at various distances. You do spectroscopy, and you can tell by the spectral lines what's being absorbed, what's being emitted. You can tell elements that are in the stars, and you can tell elements that are on a given planet, again based on spectroscopy, along with chemical studies when they finally do end up sending a probe somewhere. In fact, I need to catch up on that last Mars mission that had the rover. That was pretty cool stuff. I'm kind of behind on all that. I followed it when they first landed it and tried to deploy the little drone around the Mars, but I didn't keep up with it, unfortunately. It seems like a really cool mission. So anyway, long story short, definitely check out the NASA app and the NASA online stuff. Look for the link. I'll put the link in there for the actual 3D walkthrough things. They're really clever. Oh yeah, I was talking about the mission. So it's L-Cross, and they did. I was actually there that night. They had this call for volunteers. A bunch of us showed up with our scopes for the public, and we watched basically live. I mean, it's seconds off, right, because of the distance, but it's live crash of L-Cross into the moon, and they studied the stuff afterward. And after everyone cheered, they were doing studies for a while, and they did discover water, which is cool. They also did, there's another called LADEE, all these acronyms, and I forgot what LADEE did, another lunar device. And then my favorite was LRO, Lunar Reconnaissance Orbiter, and they basically did high resolution flyovers of the moon, best maps they've ever made of the moon, essentially, and even collected 3D information, which they use for these online things I'm talking about from NASA that you can play with. And the pictures they got were so good, you could zoom in on them and see the remaining stages of the missions that we left behind. So the lower stage of the landing platform for all of the different moon missions. And in some cases, in the early Apollo missions, they didn't have the moon buggy that came later. So everything was basically hand carried. They had an experiment they had to drop somewhere and run it later. They had to hand carry it off quite a distance, because when they launched, because there's no atmosphere on the moon, the dust just will carry long distances and just get on everything and ruin the project. So they couldn't buggy the project out. They had to hand carry it. And being such low gravity on the moon, it's very easy for several astronauts to carry a very large thing over a decent distance. But some of my friends were studying the images from, so you can download them. They're still on the websites. They're free information stuff. And they actually ran the images through Photoshop based on the mission parameters they studied. This probe went over here, this thing went to here, and they actually found astronaut hiking trails on the moon with some basic Photoshop, unsharp mask and contrast adjustments and stuff. And this wasn't advertised. This is just my friends knowing that the mission parameters found these. And then there was one mission where they had carried the probe, they're here, and they hand carried the probe way over here, walked back. So it's a wide series of footprints because it's a double trail for all the astronauts. And then they said, oh, we're going to experiment, and we're going to go over and check out this crater nearby called Cone Crater. And so they actually walked all the way around the crater, walked all the way back, and the footprints are left behind because there's no weather on the moon, there's no disturbance of any kind, so basically the footprints will be there forever. And so you can see these, you can see all they took images where the sun was at a low angle, so the material on the moon is casting shadows. So it's like a sundial effect. It's really easy to find the objects because they're casting shadows. And it was just really cool stuff. So for all the naysayers out there that say we didn't go there and there's no proof, it's all, whatever, they still obviously won't believe pictures because, of course, pictures have to be a conspiracy, and Meanwhile, you know, if you knew people who work with the moon in general, a long time ago they planted a reflector on the lunar surface, and we bounce a laser off it periodically to measure the moon distance as it changes. That was hand placed. So how did that get there, and how are we bouncing a laser off the moon if we actually didn't go there? You know, so it's kind of crazy. But some people just won't believe whatever you tell them. It's just, they'll believe really crazy stuff that's very hard to prove, and they won't believe stuff that is pretty easy to prove, even though it's still a fantastic story because of the amazing technology and smart people involved. It's very frustrating, but that is the world we live in now. I forgot to check the chat, sorry. Hey Teeny, how's it going? Yeah, no microscope stuff for a while. I'm doing on my astronomy kick for a while. I did collect some water samples in Yosemite over the weekend though, so I will be looking at those maybe tomorrow night. I didn't get any from the Merced River, but I did get a nice little spring seepage over at the Mariposa Grove where all the giant redwoods are, like the giant grizzly tree and all that stuff. So, fingers crossed, there might be some cool freshwater critters in there. So I will be doing that probably tomorrow. This stuff's in the fridge, and it should be able to keep another day. My sample from the San Francisco Bay from several weeks ago, that was actually in the fridge for almost 2 weeks because I forgot about it. Still had plenty of live stuff in it. In fact, that's where I found the dinoflagellates, which is really cool. Those are the things that cause the red tide. But anyway, that's that. We'll go back to astronomy. So those are the lunar things we're talking about, probes and such. And remember, I'll get the link for the live stuff for NASA's site. So remember to check that once I finish the stream and I go find it. So you saw the NASA tools. That's really cool. And there are some other basic stuff you can do that don't have to do with like really complicated astronomy. Say kind of a general user. First of all, some of these things are not built into the phone, or maybe not at the level they should be. So you can get really nice compass apps. So this app is, pretty sure I downloaded it. I don't think it came with the phone. I'd have to double check. But you know, really nice compass for when if you have a telescope and you want to polar align it. You need a basic compass to start. Or if you just curious, hey, I want to look west, and you don't really know the sky well at night. Obviously, people know the sun rises in the east, sets in the west, and the moon obviously follows the same path. But no moon, no sun. What do you do? So at the end of the stream, I'll do a quick primer on basically some of the key stars to look for at night and the constellations, and how to use them to find not only where north is, but how to find other constellations quickly to find your way. Not as advanced as what sailors used to do because they had no choice. You don't need an astrolabe, you don't need that kind of stuff. You can just use your eyes, but it's pretty cool how you can get around really quickly with just a couple little little pointers, little tips and tricks how to get around, and then you just grow on that from there. So basic compass app, it's called Compass. Then there's some other tools if you get into telescopes a little bit, binoculars, and you start needing some measurements. There's one called Scope Wizard, and that has some basic settings for camera settings, metric conversion, because it's of course in the US, unless you're a scientist or an engineer, we don't use the metric system, unfortunately. It's actually a good system, but that's the way it goes. So focal ratios you can calculate on your devices. You can do lots of different little things. How to do magnification adjustment, little calculations, telescope specs. You fill in the blanks and it calculates stuff for you. So kind of a simple little tool. I think this was free as well. It's kind of funny though because it's called Scope Wizard, but when you launch it, it says Skywatcher. So until you browse it and see what it's really called, the interface might confuse you a little bit. So you have that. And what else do we have here? Let me check chat again. I see changes and I'm not watching like I should. Hey Neil, how's it going? Very basic astronomy stuff that it's you may enjoy it, but I am doing it somewhat for beginners. I'll get into a little bit of advanced stuff later, just because not everybody wants to watch a beginner stream. But this is mostly about cool apps to use, how to get a starting point for stuff, and then quickly ramp up into stuff that's in your pocket. You don't need your computer, you don't need a bunch of books, you don't even need the internet. You can just use your phone or an iPad. So that was planetary compass is the next one. This one's kind of fun if you're learning planets, but you really don't know the sky. So use a version of basically augmented reality, GPS kind of stuff. I mean, it's not really AR, but it kind of acts like it because you're just pointing your device at the sky, and what is it going to show you? Where did it go? Where's my planetary compass? There we go. It's a very simple interface. You get this little thing, and there's your window of the sky for right now, because it's all time locked. Right now I picked the moon, because I know that's the moon. And if I can angle this so you can see it, because I'm going to have to, if I tilt this to go outside and I'm going to do this, right now the moon is up, but it's, as I'm looking that way, it's very low. Saturn is up already. Neptune is coming up, so a little blue guy at the bottom. And Jupiter is there on the horizon, but I haven't rotated enough because I'm trying to show you guys on the camera. So it's based on your accelerometer, it's using your GPS to know that this is what's visible from here. And it's using just really basic symbols for the planets. And you can click on each one and learn about it. You can go in here and, I thought this one would browse further. No. Maybe not. I thought you could do that. Anyway, I've only played with it a couple times, but that was a fun little thing for if you're not, he's like, you don't know the stars, you don't know the constellations. It's a fairly clear night, and you go, well, I don't know if I'm seeing planets or not because you're not familiar how different they look from the stars, because they kind of look like bright stars when you're just starting out. But this little thing will say, hey, they're up, and here they are. So you go and aim it at the sky, and it'll basically tell you exactly, as you're aiming at it, looking that direction, what you're looking at. So there's a lot of apps that use this kind of accelerometer GPS approach, kind of a pseudo augmented reality thing right in front of your face. So that's planetary compass. And then some other tools are kind of named and based on old devices. One is called Astrolabe. So it's a similar thing. Looks like one of those dials you can buy at the science stores, where you rotate one ring to show the month and the time, and the other ring, shows your point of view, and it's going to show some various stuff. So see, the sun is already down, obviously, because the sun is behind. From our point of view, the sun is down through the Earth. Moon is still right there. You can see it, little gray guy right there. This is Saturn over here, I believe. No, Saturn might be there, because Jupiter's not quite up yet. It's on the horizon. So same idea as the last program, but much more complicated. It gives you some stats. It gives you some other stuff you can browse around and stuff. So that's called Astrolabe. Then there's another one called... Oh yeah, then there's some weather-based ones. So if you want to know, hey, along with the lock screen, that gives me a quick and dirty cloud cover on my globe, you can go to one called Clear Outside, and again, based on your location settings and your local time, all that kind of stuff, it will show you, to a certain extent, kind of nerdy stuff about the current weather conditions. So when you look up at the sky, if it's cloudy or hazy, or things are shimmering because you're near like maybe asphalt or or cement that's been storing heat all day long, and it's messing up. If you have a telescope or binoculars and you're too low to the ground, you're going to see shimmer coming from the heat. But you also have a lot of other atmospheric conditions you have to worry about. They call it scene. How good is the scene? And this kind of app, Clear Outside, will show you what you're looking at. So you have all the standard calendar stuff in here. It will show you a little closer there. This camera will work. And it puts stuff in a chart form. There's some other things you can do too. Just tell it where I am. I haven't used it much. And you can put different locations in here if you want to move around a bunch. Like when I was in Yosemite, I could have put Yosemite in here because obviously that makes a difference being 4 to 5 hours away from here. So that's a fun little thing if you're, and of course there are free things on the web to do this as well, but this is in your pocket. This is where you can plan your observing for the night if you're actually going to get a telescope or binoculars out, or you're just going to stand outside and look at stuff for a while and learn the sky. Is it worth going out there? I'm going to tell you the seeing conditions and a bunch of other details. So that's kind of fun. You also have another one called atmospheric. Where is atmospheric? This one's even more nerdy, but cool. So it gives you graphs. And most of it's, you notice that some of the apps always have the typical iOS embedded menus. Little ribbon at the bottom, or sometimes a ribbon on the side or on the top. This one kind of gives you all you need pretty much right here, with probably a couple extra things as you click around. I don't want to get lost on the interface right now, but yet another tool that will show you, what's going on with your weather, what's going on with, is the sun up, is the moon up, is the whatever kind of stuff. So more fun little things like that. Oh yeah. And another one called Sundial. Where is Sundial? Similar kind of graphical tool, different colors. And it'll give you stats like you want to know about the moon, you want to know about some other things, and rising, setting, is at the zenith. So it's the, the highest point in the sky, so it's the clearest, because as you know, or may not know, when you're at the zenith, it's the clearest view you can get, assuming all of the weather conditions are fine. You're looking through the thinnest chunk of atmosphere, because it's, it's the straight point right through the virtual line of a layer of atmosphere. If you look at an angle, you're actually looking through a thicker chunk of atmosphere. So much so that as you get lower and lower and lower, as you notice if you look through binoculars or telescope, whatever, through any kind of optics, the scene is much worse when the moon or stars or whatever are much lower. They'll appear to twinkle more, or in magnification they appear to be swimming or boiling, because the atmosphere is really turbulent, or obviously more turbulent when it looks thicker. So you're just getting more artifacts with a thicker chunk of atmosphere. So your tendency is to want to just look at things as soon as they come up. Oh, I can't wait, Jupiter just came up. Don't do that unless you want to just look at it for fun, because it's going to be the worst view you're going to get. You got to wait for it to raise up higher. I don't know what the magic number is, because it depends on your conditions, but maybe 45 degrees and higher is probably the best thing to do. You can see it earlier than that if you're in a hurry, especially if the sun is going to come up and you're going to miss an object because it's only so far above the horizon. But like for Mercury, you can't wait that long. Mercury never gets higher than about 18 degrees around here. So we have mountains in the way. So a lot of times I can't even see Mercury. I have to go to the mountains nearby to look down, or I have to go to the ocean where there's no horizon, just a nice flat horizon. And then I can actually at least try to see it. But it's always going to be low. It's never going to look great. And it's not like you can see details of Mercury anyway, like the picture I just showed a little bit ago. But, you can see the color, and you can see as it goes through phases, like Venus does, and the moon. So, That is those basic apps. So like, what's up? What's the weather like? Basic stuff that's not so much nerdy astronomy stuff, just like stuff you need to know to go out and observe, and maybe how to find what's going to be available before you go out there. A lot of this information is in these other apps, you know, in kind of a planetarium point of view. So everything's embedded in this view, simulating what the real world looks like. So you can actually, and I'll show you coming up here, you can go to a browser and see the moon, or you can just look at the moon in the matrix and just blow it up and rotate around it if it's a 3D type app. What's really fun is, like, you saw in one of my other streams when I was showing you guys Jupiter and Saturn, you can pinch zoom inside the app and actually zoom in and see the moons at that given time with labels. So instead of going, like some of the older programs used to have, I've been using like Pocket programs for a long time, even all Pocket PCs and stuff like that before iPhones came out. And you know, you'd have to go to a browser window and it would give you a moment in time of the moons around a planet, and it's like a browser window. It's not a live view of the object embedded in the sky. Just like the objects you're looking at pictures of, they would give you a symbol for what kind of object it is, like a globular cluster or a nebula or something like that. But you would not see a picture anywhere near. You have to open another program or another piece of the program to see a picture. And now this stuff is like embedded in everything now, so you can just zoom in and see the picture of the object in situ. It's really, really cool. So let's go a little bit further in. You've seen those tools. Let's go to one called Sky Live. Where is Sky Live? So here's Sky Live. Well, the percentage just changed. I guess I didn't look carefully. A while ago it said the scene conditions were not great. Now it says they're very poor. But I don't know if the clouds rolled in or the data's not set right in this app. But it gives you another idea of another app that gives you scene conditions, like, oh, don't even bother going outside. The scene conditions right now are poor for your location. And it'll show you what planets are up, rise and set times, constellations are visible, major stars that are visible, where the sun is, where the moon is. So it's a fun little app that gives you, and again, more basic information for, do I want to go out and observe? What am I going to see before I even go outside and either get lost or waste time because it's not good conditions, you know? So that's another fun little app. And again, as far as I remember, all the ones I'm showing you so far have been free. I didn't track every single one of them. They at least had a free version that I'm using that I didn't pay any extras on. So sometimes when you click on certain buttons, hey, you want to add more stuff? Pay another $2 or pay another $3 or whatever to enhance the app. Some of the apps I'll show you later, I actually enhanced them quite a bit. It's like you had all the Hubble objects and all the standard, you know, not just the new, what they call NGC, New General Catalog, and the Messier objects, but you get all the IC objects and all of the, you know, they've renamed, one of the guys who wrote for Astronomy magazine, I think his family name was Caldwell, so he came up with an idea, the Caldwell objects, and it was like all the best NGC, all the best Messier, all the best whatever. You could create a Caldwell object catalog. So you can put the Caldwell objects in there. You can put other kinds of stuff. My telescope that I have recently purchased, using it for the streams, the handset connecting to the motor that counteracts the rotation and also helps you move the scope around, has a 30,000 object database. So that's stars, planets, galaxies, all kinds of stuff. But 30,000 objects is a lot of stuff, you know. So these apps will have potentially more based on what you've done to them and how, you know, how crazy you want to make the app, because you keep adding more stuff, the app gets quite large. So if you have a smaller phone, you may not want to increase the size of these apps for something you're probably not going to use. But it's there if you want it, which is really nice, because for a long time it wasn't. Okay, so that was, you saw Sky Live. Oh yeah, so here's another fun one, that one of the first apps I got on an iPhone when the astronomy apps got really good. And this is just fun for anybody to use. It's more of a gee-whiz app, but it's still impressive to this day. I'm very happy with this app. And this is the first one I used that had the kind of augmented reality approach. Even though it's not truly augmented reality, it kind of feels like a little bit. It's called Solar Walk. And this is the light version. I was too cheap to buy the whatever, $5, $6, because I've already bought so many other apps. And again, because it's gee-whiz, I don't really use it much. So right now I actually have it zoomed in. It looks like a picture. But Solar Walk has satellites in it. It has all kinds of cool stuff you can simulate. So this particular satellite, you can see the name of it there. And it's 3D, so I can cruise around it. These phones are so damn powerful now, it's amazing. And if I zoom out, you'll see the path that this guy's on, because it's actually tracking the live movements of the stuff. So I'm going to zoom out, zoom out, zoom out. There's a nice beautiful image of Earth. Keep zooming. And maybe click away from it. And go back in. You see the lines there, right? And the dots of the current position of those satellites. So if I go back to another one and click the dot, that's the same satellite, so I didn't try a different one. Let's see what other satellites we got here. Oh, see, now it's pivot. Cool thing too is it knows, hey, you want that one, it's going to pivot around that. So it's got, I just set the center point, so let's pick on another one. Nope, sorry, I keep hitting the same one. Sorry about that. Being clumsy here. And again, this is more just a goofy feature. You don't really, I shouldn't spend too much time on this, but it is pretty fun. So here's one going into the dark area of the Earth. Let's click on. Oh, that keeps rotating there. That's nice to get the Earth at night imagery with all the different lights of the cities and stuff. Why is it not selecting it? I think I'm just missing it. There we go. There's another satellite. Oh, a fat, chunky satellite. Oh, there's Jupiter way in the background. So Solar Walk is funny. They basically condense space. So Jupiter looks pretty big right here next to the Earth, but it's diagrammatic. It's not supposed to be accurate. But this part is fun because you can, let's look for different satellites and stuff, and you can go to the moon if you want. Let's see if I can go. Click back on Earth, and I can pivot around Earth. There's the moon. I can go look at the moon. Pretty decent resolution shots of the moon. And I believe it also has like lunar missions on here too that you can explore further. Like I was talking about before with the hand-carrying exhibits and stuff. But pretty impressive 3D data on the moon. I mean, you've seen some of my scope shots that look kind of like this, not this clear, but you get the idea. They've used real information here. So anyway, so that's that one. If you just kind of click anywhere, you can do the whole solar system. Let's see, there's a way to do the center, I think. And also this has the aiming thing I was talking about. So if I click this, I'm actually simulating right now. Let me change the brightness. Some of these apps need more brightness. Now you can see the asteroid belt. Go further out, and the sun gets this nice J.J. Abrams lens flare effect. I see the lens flare right there. But yeah, you can rotate it around the solar system. It's nice 3D information. You can go to another planet. So there's Saturn, beautiful images of Saturn, and all the moons have proper information. They're not just basic shapes. You're getting, you know. Let's see if I can find my favorite real quick here. Where's Mimas? No. Here? Is it Enceladus? Is it here? No, that's not it. Sorry, I'm just goofing around. There's Pluto in the background. No longer called a planet, unfortunately. Poor guy. Lost his status. It's all Neil deGrasse Tyson's doing. He's one of the big proponents of that. Oh, Uranus. There we go. Right. Anyway, so you get a point. I'm just kind of goofing around here. You get it shows you very lightly the paths of the planets. You can animate this, turn stuff on, and watch stuff spin around. Zoom in, get some nice shots of the sun. I'm pretty sure you can change the view of the sun too if you want to see it hydrogen alpha or visible light, sunspots, all that kind of stuff. Oh, it's Jupiter. And I think you can do the shadow transits on here. I haven't tried it before, but I've watched real shadow transits of Jupiter before. They have beautiful imagery there. It's just amazing. You know, got it too blown out. So yeah, if you're lucky, and there are apps, these apps will tell you the shadow transits. You can actually dial it in and go, when am I going to see the Ganymede go across the planet again, and when can I see the shadow? And you can figure all that out, which is pretty cool. So that's fun, and again, you can have it in the mode where you can tilt it, and it'll actually show you exactly what you're looking at. In the Star Walk version of it, that's the planet. That's the Solar Walk. But if I go to Star Walk, bring up Star Walk now. It's the same company makes both of them. Here's Star Walk, and I do have the full version of this one because I bought it a long time ago. So it's a planetarium type program. There's like, it shows you these big arrows like south, west, north. I have it set now where basically there is a horizon, but it's not showing like an Earth. So you can still see what's not visible down below us at that point in time. It's already default set with the constellations and the shapes of the constellations, so you know the artwork. Why the hell is a Big Dipper called the Big Bear, Ursa Major? Well, here's the Big Dipper right here, and the rest of it is his head and the feet, the legs coming off of here. So the full constellation is the Big Bear. But Big Dipper is called an asterism. It's a very bright, distinct portion of it that people are more familiar with. And these other ones are sometimes kind of hard to see because they're different brightness. Big Dipper's really, really, really good. And I was going to do this later, but since I'm here, I'll just show you real quick. A little trick to find a North Star called Polaris is you take the two bowl stars of the Big Dipper. So there's the handle, there's the bowl. Take the two bowl stars, point that way, and there's Polaris right there, the North Star, which is the Little Dipper, which is kind of basically looks like the Little Dipper's pouring into the Big Dipper. It's upside down. So you find the Big Dipper, you're pretty damn close to finding North. There's North Star right there. Now this is true north, not magnetic north. So obviously your compass is going to go magnetic north. So you have to know the correction for that. But this is as close to true north as you're going to get. In the south, if you're a southern pole person, in Australia, New Zealand, stuff like that, there's no 100% South Star equivalent, but the closest one is in this constellation called Octans. It's Sigma Octantis is how you talk. So when you use the Greek letters of the various stars and high brightest to not so bright, Sigma Octantis is the equivalent to this southern pole star. So if you're doing polar alignments down there with the scope, you would use that scope instead of that star instead of Polaris, because you can't see Polaris from Australia. So anyway, so that's a quick thing. So you get if you want to learn the artwork, there you go. And these programs are cool too. Not this one because it's more basic, but there are other programs you can do, like Native American constellations, Chinese constellations. You can go through all kinds of different cultural stuff and learn the constellations they created with the artwork and everything. It's really, really cool. Anyway, so this one also you can turn on this little thing. I think I have to do it in this mode. Settings. And this has like music and sound effects. Kind of like the music I'm playing in the background. It has some kind of spacey music kind of stuff. So picture caching. There's a setting here to turn on the auto rotation. Oh, there's also night mode, so if you're an astronomy user, red light you could still see pretty well with, but your eyes aren't as sensitive to red light, so it doesn't stop down your pupils. So you can maintain your night vision mostly with a red light. So the interfaces in a lot of these programs, they change to red or a shade of red until some other program opens up and blinds you, right? So, but it's nice to have this app with an option like that. You can turn on satellites, which you already saw. There's a thing called a Telrad, which is a viewfinder that a lot of telescopes use these days. It's just basically projecting a illuminated reticle on the sky. So you look through a little eyepiece thingy. In fact, I left mine downstairs. I was going to show it to you, but there's an equivalent one that's just a dot, and you put this on your telescope instead of a small viewfinder, which is the tiny telescope, which is often kind of a pain to use unless you get a nice one. If you align the laser pointer / Telrad along with your, just like you would your viewfinder, your little viewing scope, you can just look at the sky put a virtual dot projected on the sky and just move your scope either manually or with your paddle controller, and just jump around really quickly. As you learn the sky, it's so much faster this way than like, oh, I gotta look for that one thing. No, you just look in the sky, and if you know, Saturn's over that way, I don't need the app. You just look through the thing and start moving the thing until your scope the red dot gets right on top of Saturn because you've aligned it. And it's like this Telrad thing. So if you zoom in, this is what a Telrad looks like. It's a series of illuminated circles. The thing I use is just a center that's basically a filled dot. It's just a laser pointer, essentially. And speaking of laser pointers, again, I was going to talk about this later, but I'm already on the subject. When you're doing training stuff, showing the public stuff or showing friends how to find stuff, one of the coolest things you can do is use a real laser. In this case, a green laser, because again, the eyes are very sensitive to green as opposed to red. So use this laser pointer, and this is a 17 milliwatt ND-YAG laser. So if you guys know about laser technology, very dangerous. Don't put this in anyone's face. You can actually blind somebody with it. And I have one that's even a watt, like literally a blue laser that's a watt, and it will burn paper instantly. So I'm very careful with that one. But it's like, you go outside with this, it's like Star Wars. You have a nice beam that goes up into the sky, and it looks like it goes forever. Obviously, it only goes probably, 100 feet or something like that. But it stays a nice tight beam, so you can use it to point constellations and star formations, and that was that planet, and there's that planet. So the combination of something like a Telrad on your scope and a real laser, or you can even, some people even mount the laser to their scope and just point the scope wherever it has to go. Problem with that is if there are aircraft nearby and you have a laser pointing up at them and they see you, you're going to get in big trouble, because even though it may not really do anything to them, it's going to distract the pilots, and they don't you have to be very responsible with these things. But you can buy these now from China and other kind of things online for like, I don't know, $30 now, $20. They used to be like $150 when I bought this one, but that's how long I've had it. So, and then the red light thing again, since I'm all my stuff together on this little lanyard, red light is very important. So here's a red flashlight, but on the black so you can see it. So this light stays on. You can basically sit there and like look at your charts, look at your eyepieces, look at your telescope, and the whole time you're using the stuff, you're not blinding yourself to being like you just started observing. The roughly 20 minutes it takes to get full dark adapted with your eyes, based on your, depending on your age and your health and stuff like that, to get the full open, you know, fully open state of your pupils, of your iris. Could take about 20 minutes, sometimes longer. And so you use lights like this to do your thing. So I'm jumping around a little bit, but since it came up, I thought I'd mention that. Yeah, so this program's cool. You get the shapes, and you can turn all this stuff off and just look at the beautiful sky and stuff. But that is Star Walk. And you go outside, and you can just, like I said, aim it at the sky and rotate it. You can kind of see it doing it now as I'm turning it. It's locked to the sky based on my accelerometer and my GPS. And I go, hey, what's over here right now? Oh, what's over there? Oh, okay. So Milky Way is that way, all the way up, all the way down to the Sagittarius. And you know, you can see what's up and turn all kinds of things on and off if they're too distracting. It shows you the star names and where the planets are and stuff like that. It's a very economical program and very powerful and just a beautiful app. And if you turn on the space music, you can kind of trip out while you're using it. Also has some little noises like ding, 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 little like sound effects you can turn on and off too. So when I first got it, I used it quite a bit, even though I knew the sky pretty much already, but it was just fun. It made astronomy really fun. So those are Solar Walk and Star Walk. And then you get into stuff like globes. We were talking about the moon earlier. You're like, well, I want to study the moon because it's really easy to look at, and it's really easy to use a really cheap telescope to study it. And yeah, my first department store telescope I actually bought for myself because my parents didn't buy it. I think it was $100. I was only making money part-time working at a children's zoo, and you're going to school, so I didn't have a lot of money other than for gas and some other incidentals. But I really wanted to get started in astronomy. Join the local club and go to the events with the nice big scopes at the club. But then it's like, well, I want to spend my own time doing stuff late at night or whatever, take it somewhere on a trip. So I bought a really cheap department store refractor, 60mm refractor. So it's big, well, at the time for me, big objective on one end, and then your eyepieces or ocular on the other side. You have different size eyepieces. The smaller the number, the more magnification you get out of the thing. So a 22mm is a pretty standard low power, low to medium power eyepiece. You know, often you get 40mm if you want like a wide field to find things, and then you put the higher magnification in to look at detail. They can go down to 6mm and further, but by then on a cheap scope, it's so dark and muddy, unless you're looking at the moon, and the scene is really good. It can be pretty impressive even in a cheap scope, but quite often the atmospheric disturbance, the quality of the optics, you're going to get kind of a muddy, washed out, swimming view of the moon. It's not going to be super clear. But trust me, I did it many times anyway because it was fun. I didn't care that it didn't look that great. But as you get more into the stuff, you want better quality and make it look more like the pictures you've seen and stuff. You get better eyepieces, get a better telescope, all that kind of stuff. You start thinking about that stuff. But when you're getting new about this stuff, anything is cool. The first time I looked at Saturn with the scope, it looked like somebody put a sticker of a picture on my lens. That's how good it looked. It's just very small, but you can see the rings, and you can see, you know, Titan, the moon going around it, and it's just like, wow, this is so cool. And I have the cheapest damn scope you could get. And now with the prices going down and the quality going up from places like Orion, like telescope.com, or some of these other companies that sell things now online, you can get a really good telescope for like $200-300 that 500 times better than what I got for $100, you know, back in the 80s, late 80s. So anyway, so that's, you want to get into like maybe look at the moon. So you have moon globe, and it gives you some nice thing. You can spin it, look at the dark side. So you can turn all this stuff off if you want it, simulation off, and just see the entire moon as a map and not as a simulated illuminated object from Earth. This is more your typical orientation here that you would see. But what's cool is they give you some stats here, but then you can also do this. Pick a mode, and you go, okay, here's terrain, let's jump around. It's going to zoom in really close and show you terrain features. It can show you craters with names and some fun facts about that, and jump around again. And here's another place, and jump around again, and jump around again. And so it's like a little tour. So the dark sections, this is the Sea of Crises, Mare Crisium. So the early people who studied the moon thought the dark spots were seas, or mare in Latin. So of course they're not. They're just lava fields that are darker. That they're not these mountains that you have on the moon, or craters and such. I mean, they have craters in them, but they're old lava fields from back when the moon was geologically active. But yeah, you just jump around in this mode. It's kind of fun. And the thing I was talking about on the NASA website can do stuff like this as well. Then you have a different mode. You go spacecraft. Where does some spacecraft land? There's one of the landing sites right there inside that. So you can zoom in and zoom in and zoom in to a certain extent. And it will give you details about that mission. There's Apollo 11. Etc., etc., etc. So that's fun. And then you have the what is this one? Oh, this is the regular mode, so you can zoom in like I was before. So again, nice moon map. Turn all the things on and off if you want to learn the names of everything, or just enjoy the beauty of it, because it's real data. Those craters are amazing. There's a nice mountain range there. You get a lot of the craters are really cool too. You get that, like you get when you drop stuff in liquid, you get that crown splash, or they have a plume that comes up from the impact, and it often settles into like a spire in the middle of the crater. And it, when you look at the moon with real light, not the simulated 3D stuff from the actual images, but with the lights changing over time as the days go by, you get the sundial effect, where the spire is basically casting shadows from the moon at the from the sun at the right angle, and you get this kind of little sundial effect. So you look for little dots in the center, and they're raised areas from the impact. Beautiful stuff, though. There's a nice little formation in the middle there. So that's Moon Map, or Moon Globe. Sorry, the app called Moon Globe. They make also one called Mars Globe. Where is Mars Globe? Mars Globe, Mars Globe. Where did I put it? I have too many apps open. Mars Globe. Sorry about that. Because I have so many apps on my phone, it's nice to have these already open. That means I have to browse through them real quick. Oh, here we go. Mars Globe is cool. So right now it's again simulating Mars as it is right now. So you get a dark side and a light side, just like the moon is. So I can turn all this off and make sure it just looks like a giant full color, fully illuminated map on a globe. But this is nice because it's simulating. You know, right now you can't see Valles Marineris, Mariner Valley. It's Mariner probes like Mariner 10, Mariner 11 went to Mars a long time ago to get primitive pictures in the 70s. But good pictures at the time. But I think those are the ones we had the face of Mars. Might be Viking, I'm thinking of. But the famous face of Mars. And then they went back, you know, many years later with better quality cameras and different sun angle, and proved it was just a wacky mountain formation. It looked nothing like a face. But all the alien fans out there were thinking it was an ancient civilization on Mars, just like Percival Lowell in Lowell Observatory used to think there was a canal system on Mars, and he drew all the canals out. He's kind of a maniac. But anyway, so Valles Marineris is cool because Valles Marineris is basically the length of the United States, but it's a Grand Canyon the length of the United States and way deeper than our Grand Canyon. So our Grand Canyon is kind of a joke compared to Valles Marineris. And there's some cool online simulators where you can actually just have a fly through of Valles Marineris in 3D. That's quite fun. So I wanted to show that. You can't see it, it's dark, but I wanted to show it because it's just a fun feature. But when Mars was at opposition many times, which means it's opposite the sun in the sky, and also what you call perigee, which is close to the Earth. Apogee is far from the Earth. Perigee is close to the Earth. Aphelion is far from the sun. Perihelion is close to the sun. And then there's opposition, which is opposite the sun in the sky. So we had opposition and perigee of Mars many times when I started getting into this stuff. 1988 was the first time, and my friends in the club are so amazing. They had these clever tricks for. It was so close, you could see all these amazing details of the planet, all these dark markings, and you could see dust storms come in and just cover things, and you could see the polar caps, and it was just really, really fascinating. But because it was so close, they figured out the trick where if you put a little blocking disk in your eyepiece to block out the bright disk of Mars, you could see the faint moons going around Mars called Phobos and Deimos, which are basically captured asteroids, from what they believe. We were able to watch those and actually watch them disappear behind Mars. And this is like real-time stuff. It's like, holy shit, it was amazing. But yeah, there's all kinds of cool structures on Mars. I'm trying to find the one called Syrtis Major, because in the scope, it looked like a giant version of the country of India. It's like this kind of a rough triangular shape. So it's one of the most obvious things. There's also Olympus Mons, Mount Olympus on, they call it Mount Olympus after the famous Greek home of the gods. And it's a massive volcano. I think it's about the size of Arizona. Maybe a little bit bigger than that. I have to double check, but it's big. So even though Mars is smaller than Earth, they have this huge valley. They have these huge volcanoes. They're a really interesting place. So anyway, Mars Globe, another cool app. Let me check the chat because I'm way behind on chat. Sorry, guys. Hey, everybody. Sorry, Neil, I didn't see all your comments. I was yakking too much. Hello. Thanks for coming. I know I started this kind of late for people in my part of the world to join. So I'm a night owl, but it's a good time for all you guys in Europe and the UK and stuff like that to watch, which is great because it's unless you're working, being busy, and don't get busted online, you can watch the stream in your morning. So anyway, so let's see what else we got. So that was all kind of the fun kind of gee whiz apps. What's going on in the sky, what the weather conditions are, what's up to look at when it's up, like little globes, like Mars globe, Moon globe, simulator stuff, like where stuff is in the solar system, all that kind of stuff is kind of fun. And then we started getting into some of the more serious apps. A couple of these start out pretty basic, but they have a lot of features I haven't turned on, but I would be happy with any one of these apps by itself in the old days when there weren't too many choices, especially in your pocket. So, like, here's one called Sky Portal. If I could find it, there's so many apps open. Sky Portal. Hello, where did I put you? Sky Portal. Holy smokes. Too many apps for sure. Oh, there we go. Okay. So again, nice looking app, very basic. Has the typical iOS ribbon at the bottom for functions. You don't have tabs, you just have little icons. Some stats at the top, you know, time and date, right ascension, declination. So right ascension is celestial longitude, declination is celestial latitude. So right ascension is hours, minutes, and seconds. Celestial latitude, which is declination, is in degrees, minutes, and seconds. So if you know anything about, you know, map coordinates on Earth, just project them out into space, and that's essentially what you're looking at. They just have different names. And just like you could memorize any place on Earth, if you know geography well and you're studying in school, or you're just into the stuff for fun, or traveling a lot, it's easy to remember where stuff is on Earth. It's also easy to remember where stuff is in the sky. It's just, you just gotta put the time in and, you know, study your constellations. Right now I have all the constellation shapes turned on. So, and as you zoom in, it starts putting the names of the stars, if you like all that. You can turn all this stuff off if you want, but for example, this is the Great Square of Pegasus. It's another asterism inside of a constellation, just really obvious bright stars making a shape. In this case, they're also showing the colors of the stars, which is kind of fun. They're not just white or blue objects on a black background. So Great Square shows you the body of Pegasus, but you know, the wings and the legs and the head are all different branches going off in different directions. And if I turned on the artwork, you would see that. And then you have something like Pisces, which is this big V right here. It's basically a string holding two fishes, like a fisherman who's got the fishes on the line. And then what's fun is, you know, you want to find some cool stuff, so you have these landmarks. So Pegasus is, I love it when I see Pegasus up, because that means I can find Andromeda. If I don't know Andromeda, I can find it very easily. You take one of the branches here off of Pegasus down a couple notches there. You also come over here to Cassiopeia, which is an M or a W based on the time of year, what angle you're looking at it. And what's really cool is part of Cassiopeia becomes like an arrow, and you follow this line down, and you zoom in, and you can basically find the Andromeda galaxy. So it is not, I think this program doesn't have it turned on right now. You can turn on and off deep sky objects. But essentially, I'll show you another app that I haven't enabled on, because I don't know this app. Oh no, there it is. There's the circle. There's the circle. I can actually see it here. So I zoom in and zoom in. Now these new apps, like I said, the images are embedded in the matrix, so you just keep zooming. First you get the shape for the object. Yes, that oval means it's a galaxy. Zoom in, zoom in, zoom in. Oh look, there's a picture. There's Andromeda galaxy right there. Keep zooming. Keep zooming. You get the nice dust lanes. If you saw my stream from Yosemite the other day, you could actually see one of these dust lanes in the picture, even though it's not a great picture. And then because they captured it in the shot, and I also go to the browser so you can read about it and see a better picture. This is M31, has a companion called M32 right next to it. But M31 is fun because it's a giant spiral galaxy, very similar to what our Milky Way galaxy looks like. It's not a face-on, it's not an edge-on, it's kind of an angled view of the spiral, so you can see it going into the distance. And it's the farthest thing you can see naked eye. 2.2 million light years. Some references say 2.6, but very, very far, and you can see it naked eye on a decent night where you know where to look. Pretty impressive. So M31, M32, the M is the Messier object designation. So there's basically 110 Messier objects. And off just for fun, in the same field of view, if you zoom out enough, you can get 3 galaxies. They're part of our local group. So you have M31, M32, and NGC 205, which is over here off screen. I was looking at it when I was up in Yosemite. Really, really nice. And then nearby, there's another galaxy in Triangulum called M33, and that's also part of our local group. So if I zoom out a little bit, and it should be enabled here. Let's go to Triangulum. Zoom in. Look what that is right there. There it is. It's called the Pinwheel Galaxy, and here is a spiral that has more face on than Andromeda, and you can see the arms really well, and it looks like a pinwheel you can play with as a kid. Washed out in here. Drop it down a little bit. So, really nice. Now this is not a 3D view app. It's just basically simulating the 2D view you have of everything, but there are other apps where you can actually do 3D views of galaxies. Pretty impressive. So that's M33 in Triangulum, right next to Andromeda and the other guys, and they're part of our local group, but they're also very far away. So at some point you zoom and then it disappears. Just like it's not quite a naked eye object. You can see it in binoculars on a good night, but you can't see it naked eye. It's only Andromeda you can see it like that. So yeah, there's some ideas. This is a pretty basic app, much fancier ones than this. Even has a little telescope icon down here, meaning you can hook this up and do telescope control. Where it's all synced up, you can just go to this object and hit, and it goes. This stays here, and then you hear your thing go. And then, if you watch my streams lately, I've been doing the computer control to show you guys where stuff is in the sky, and also you can hear the motor in the background, and the little orange crosshair goes and lands right on the object that I'm looking at. So having apps with telescope control in your pocket, really powerful. And there's all kinds of other stuff I'll just skip over because I want to show you better apps than this. But this app is pretty basic and it has a lot of cool features. So that was Sky Portal. Chat real quick. Actually, this version of the chat is kind of annoying because it doesn't let me magnify the text. Let me quickly go to the YouTube view and look at that chat because I can pop it out and make it bigger. Okay. Oh, you get the week off. That's cool, Neil. Hopefully, if you got some decent weather, you can go out and look at some cool stuff in the sky. All right. So that was Sky Portal. Let's take a look at another program that's specific. It's not a generic program like a planetarium program. So per se, I mean, it has some of those features, but it's aimed at looking for planets. And again, I've only used this one a little bit, but gives you the same kind of idea of it's locked to the sky. So as I go out, and right now you can see it's got some other markings turned on other than the constellations. So you have this thing called the ecliptic, which is roughly the plane of our galaxy and plane of our solar system, I should say. And if you're not sure when you look up in the sky if something's a planet or not, and say the conditions are perfect and you don't have too much light pollution and the scene is very good, it's a very stable thing, so you're not seeing any twinkly stars. You're getting nice, clear, sharp star images that are not twinkly, because twinkly is indicative of atmospheric disturbance or weather or whatever, bad scene basically. Twinkle, twinkle, little star is not a good thing. It's a cute song, but when you go out, you see a lot of twinkling, like, oh, the sky's terrible right now. But you still look if you're into it, and just don't expect to maybe take any good pictures or have the best view you ever had of something. But the planets are very big compared to the stars because they're so much closer, and they're also quite big, of course, like Jupiter and Saturn and stuff. So when you look up and you see a bright object, and you don't know the sky very well, but at least you know where the moon was, if it's still up, or where it normally is in the sky. Maybe you tracked it over a couple days, or as the sun went down, you kind of knew roughly in that part of the sky where the sun had gone through, and then it got dark, and you can see that. That's the ecliptic. And so if you follow the ecliptic, you can find the planets pretty easily, even without really knowing initially what the hell you're looking at, because they're fairly bright objects. At least the big ones are, as you get closer to us in the orbit. But they're Jupiter's always very bright. Venus is always very bright. In fact, Venus is always called the evening star or the morning star because it was perceived to be just a giant star, and they always, because it's close to the sun, just like with Mercury, you only see it in the morning or in the evening. You don't see it at night because it's too close. It basically stays fairly near the sun in the sky. But if it's really bright and it's middle of the night, obviously not Venus, and obviously not Saturn, because Saturn is fairly bright, but usually it's kind of a muted cream color. It's not white. It's not a bluish greenish color like Neptune or Uranus would be, which are binocular objects quite often, but not naked eye for the most part, at least not that I've seen. But they're still pretty bright. They're just very small, and if you don't know the sky very well, you're not going to know, is that a star, is that a planet? Once you get in a scope or binoculars and you see a disk and not a dot, not a tiny little dot, you pretty good indication that you're looking at a planet, especially if it's one of the big ones. And it generally doesn't twinkle as much because it's so much bigger in the sky and so much brighter. It's just perceived to be more of a stable object, and again, more like a disk when you magnify it, not a dot. So little things like that help you remember what you're looking at. And these apps like this will show you where they are in the sky. So there's the moon. Sorry, I'm off camera here. There's the moon. And I can click on it. And let me actually turn off the... You've seen the tracking. Tracking works fine. I'm going to turn tracking off so it doesn't keep doing that. And you can see... Turn off the tracking. Oh. So you've got a little Earth browser here. See the Earth at night, Earth rotating around with a nice map. It shows you the planets that are up currently. Got little graphs showing the planets that are up. There's the map mode. There's the basically kind of an orrery presentation. Although an orrery is mostly about the solar system, but it's again linked to your motions. So kind of like the other app I showed you that showed the planets that are up. As I'm moving here, and notice how the planets are staying over there in their right spots. So Jupiter's already come up, and Jupiter's also showing itself to be over on that side of the app. The moon is going down, Saturn is still here, so it kind of helps you see it in a different way with the star background. Compared to the other program, I had no star background. It's just a very basic presentation of the planet alignment. And then there's a way to turn this off. Is it this? Okay, now we can toggle to the normal mode, where it's like a planetarium. And again, this is very basic layout. It's not deep and not simulating the sky like a real sky, like some of the apps I'm going to show you do. It's more diagrammatic, but it's still nice, and it gives you the orientations. And you got Jupiter here. You can zoom in on Jupiter. Not too far, but you get an image of Jupiter and an image of Saturn and the moon. but it's not fancy like the other apps. And of course, Earth is here as a horizon, so you know, nothing's visible down there. But if you push it, it gives you a transparent green. So yeah, there's the stuff that's coming up or already gone down. So you can kind of keep an eye on, like, oh, that's supposed to come up later. Okay, now I know to look. It's got the Milky Way in there. You can see the Milky Way represented, which is looking into our own galaxy. And the center of it is roughly around Sagittarius. So you see what's already down. See Mars, Mercury, the Sun, and Venus, all next to each other. Mars was good a few months ago. We were looking at it a few months ago. But, because we're passing it, we're going around faster than it is because we're closer to the Sun. We have a smaller orbit. So you have this concept of retrograde motion, which they often, in astrology, they often talk about, oh, the Venus is in retrograde or Mars is in retrograde or whatever. It's like, well, yes, but it's just our point of view. It doesn't mean anything other than it appears to be going back the other way because we're passing it, or it looks like it's going forward again because we're, it's just our orientation, and it's all a relative view of how things are moving in the solar system. There's no magic in there. Like, oh, I feel terrible because Mars is in retrograde. No, you feel terrible because you have maybe some depression or some chemical imbalance or not enough sleep, bad diet, bad day at work. There's all kinds of reasons why it's not Mars in retrograde. You can't blame Mars for your problems. So, anyway, so people try to do that. It's kind of silly, but I guarantee you, there's plenty of stuff in the horoscopes and stuff online that don't make sense. One of my favorites is, the ecliptic also follows the zodiac, zodiacal constellations, the 12 constellations of the zodiac. Well, because the zodiac is not, we have our view of the universe changes as we go through our orbit, and we have the planet wobbles on its axis. It also prescribes it's called precession, or prescribes a circle as it rotates, and sometimes the wobble, it's you still have your phases, your seasons, because you have the tilt of the planet. So in the winter you're getting the lesser amount of sun because of your tilt, and in the summer you're getting the more brunt force of the sun because of your tilt. But you're also affecting your view of the sky because of as you go through, as you're rotating and as you're revolving around the sun, over time, it's not 100%. There's a wobble, just like the stars wobble. Stars wobble because we have planets going around them and stuff. So they actually through basic physics, you have things interacting with each other, and even though planets are a small force compared to the force of a sun, the gravity and such, they still exert a force, and they make it wobble enough. This is how they found planets around stars long before they could image them. And I'll show you an app called Extrasolar or Exoplanet. I think it's called Exoplanet. It used to be called Extrasolar Planets, now it's called Exoplanet. And it has thousands of planets they found around other stars, not just because the data they studied of stellar wobbles. And in fact, I actually helped collect some of that with a friend one night. Not that I was collecting them, but I was hanging out with him. A friend who worked at NASA Ames up at Lick Observatory in the mountains nearby, Mount Hamilton. And we went up with the liquid nitrogen cooled camera on a really nice reflecting telescope there, and he was capturing frames of stellar wobbles. Very boring work, but you go back and analyze all those images, and you can determine what's the mass of the stuff going around it, and then based on that and some more calculations, you can figure out how many objects are going around it potentially. Are they Jupiter-sized objects? Or are they smaller objects? And maybe over time, with more data, will or the possible distances from it, and then you have to start, you know, getting more data on imaging, and you know, as the planets go in front of the sun, the star you're measuring, are they, you know, what's the spectral complement of the star, because now you're blocking some of the light coming from the star and potentially revealing other chemical signatures as the planet's going in front of the star. So all this really cool stuff, very esoteric, but all led to finding these extrasolar planets. So I'm going to get out of this app because it's pretty basic, and I'm going to show you that really cool app called Exoplanet. And it's one of my new favorite apps because I didn't know it was this cool. When I first used an app like this, I thought, okay, they'll show you where the planets are. That's kind of interesting. But wait till you see how they do it. So here's the interface for Exoplanet. And there's a bunch of, you know, constellation stuff in here, and nitty-gritty details, database of all the planets they found around other stars. Look at that. I'll be here all day. It's just thousands of them. So here's what's really fun. Go to the Milky Way button. And I actually paid a little extra because it added all the Hubble observations to this as well. There's a whole bunch of other database objects in here that I had to add. So I said buy now. It apparently forgot that I already bought it, but I'll say buy now. It goes, oh, you've already bought it. Oh, no, they added some more stuff. So, okay. Let me add it real quick. They keep adding little goodies to it, but it's so much fun, I'll definitely keep updating it. So here's where you start with the Milky Way model. And look at all this stuff. It's got words upon words upon words, and letters and numbers and all kinds of stuff. And all these red dots. And this also rotates. And so it's 3D, right? There's our Milky Way represented in the software. Obviously, we can't photograph our own Milky Way at this angle. We can only see it from the view we have of the fat line in the sky called the Milky Way. But watch this. I'm going to zoom all the way into the sun. And all the way in, all the way in, all the way in, all the way in, all the way in. There are, basically has all of our orbits around the sun. And these measurement circles. So it starts in, what is this doing here? Astronomical units. So 1 AU, astronomical unit, is the distance from the Earth to the Moon, to the Sun. That's 1 AU. We have, you know, we're self-centered. We measure based on our experience. So 1 AU is that distance. So, you know, Jupiter's like 15 AU. Saturn is further than that. I forgot the exact number, but we measure the planetary distances in AU because light years a long way. You know, the closest star is 4.2 light years. Alpha Centauri. It's this Proxima Centauri. Alpha Centauri is basically a cluster. It's like I think it's a trinary system. It's more than a binary system. And there's Proxima is the closest companion of Alpha Centauri to us. That's 4.2 light years or something like that away from us. So that's light traveling 186,000 miles per second for over 4 years. Pretty crazy. That's pretty far, but that's nothing because this is, you know, measures in AU, and then you zoom out and zoom out and zoom out. It starts getting into parsecs. So what we have here, now we're at 300 astronomical units, 1,000, 3,000, 10,000 AU, further, further, and at some point, as I start elucidating all the spikes here going to the different planets, And now we're into 10 parsecs. So it's parsecs. They use, of course, the famous joke in Star Wars is they misuse the word parsec. They say we made the Kessel Run in whatever parsecs. I've forgotten that. I should be able to quote that, and they made it sound like it was a measurement of speed. And they tried to fix that in the subsequent Star Wars movies, showing the Kessel Run, and I think it was in the Solo movie, and that it was actually a different path he took. So he took a shorter path in parsecs. But you know, when they talked about in the original Star Wars, the way they talked about it, it was like, I made it in so many parsecs. It's like, it made basically everyone think it was a measurement of speed when it really is a measurement of distance, and it's parallax. So when you look at the, just a quick example of parallax is, you put your finger out and you close one eye and close the other eye back and forth, and your finger jumps back and forth. You have two different vantage points of the same object. That's parallax. And so, when we're studying objects far, far, far away, you can actually measure the parallax of the object based on, two points on planet Earth, two ground-based telescopes, two radio telescopes, whatever, and you can measure the parallax. And it's parallax arc seconds, essentially. It's just a very small measurement. And I can't explain more than that because I forgot the details, but that's essentially what parsec is. And so you just go, and look at all the stuff that's flying by. It's all these planets they've already found around other stars. To the point where you're actually, okay, now we're outside of Milky Way. We only can find planets in Milky Way for now. Can't find planets in other galaxies because they're so damn far away. But this app is mainly based around extrasolar planets, but guess what? You pay a little extra money, they add the Hubble information about some other objects. And now you're going out 30 kiloparsecs outside of our galaxy. And now you're at 100 kiloparsecs. And watch this. Look what's starting to show up. Hey, there's our local group right there. There's M31 and MGC205 and M32, the ones I showed you in the other apps. And it's 3D, so you can rotate around and see where everything is in relation to each other. And you zoom out, and you zoom out, and you zoom out. There's some other galaxies, NGCs and ICs, and look at all those galaxies. And they all have little graphics, so you can tell what galaxy it is by the color, the shape, all that kind of stuff. And you zoom out. Now we're at 10 megaparsecs. Now we got the Virgo cluster of galaxies right there. It's a beautiful thing in the summer, spring, early summer, late spring. That's 30 megaparsecs. And now we're at the Cancer cluster, the constellation Cancer, and the Hydra cluster, and the Centaurus cluster, and this thing called the Great Attractor, which I'm not that familiar with. Ophiuchus cluster, another constellation. Keep going. Corona Borealis is a constellation. Keep going, keep going. And eventually you get the limit of our data right now, which is the cosmic background radiation, essentially. And that's as far as the app goes. And you can't see it because it's overexposed. I turned it way down. You can see that false color image of that stuff. So that's in an app that's about extrasolar planets, and you got all this cool stuff about galaxies and their orientation, and I don't have another app that does this. So I was so happy to find this. I love this thing. So anyway, that's the exoplanet app, and I just spent another $2-3 on some more data. So I'm already maybe $10 into the app, but I love it. So if you're into the stuff, it's worth the extra money. So that is a nice special app. We have some other planetarium type apps. One of them is called, go Skywatch. Now this is an app I used for many years on the iPad at the astronomy star parties we had up at Glacier Point in Yosemite. Public comes by, they want to see stuff. So here's the fun thing: we're talking about red vision before. Well, most of these apps don't have a red mode, or if they do, you still have like white borders around stuff. Well, you buy this red acetate, you put it over your iPad screen, or you cut a smaller piece and put it over your phone. Tape it on there, however you want to do it. It looks bad now, but when it's dark, you don't see reflections like this. And you can turn the brightness up on your phone, because right now I have it down for the camera. But if I turn it bright and put this red film over it, it's plenty bright, but not bright in the bad way that you're ruining your night vision. So you can do this on your phone, your laptop, your iPad, whatever you're using to look at your stuff. My friends who do astrophotography with like $5,000, $6,000, $7,000 camera systems, where they spend all night just taking images. They also put this over their laptop because they want to sit there looking at a computer screen taking images. So red acetate, or you can buy the hard red plastic that's custom fit to put over a screen or whatever. This stuff is like gold. You can also make a red flashlight out of a regular flashlight if you don't have an LED, like this one is a red LED. It's a red LED. Of course, it doesn't look red on here because my hand is reflecting too much, but you can see it's red. You can basically take a white flashlight, standard incandescent bulb or white LED, and put some of this inside the cap of the flashlight, or tape it on the outside of it, and you have a red flashlight without having to buy one. So this stuff comes in handy. Buy it at a hobby store, art store, whatever. Buy it online. Very, very useful. So who else we got here? Anyone else join? Neil's still there. Thanks for hanging out, Neil. Hey Dan, how's it going? Sorry, I'm way behind on my chat here. I'm a bad boy. Yeah, that's true about what you're saying about the interface. Yeah, there is a mode you can do on iPhone now and iPad, and that you can change the color of your interface. And then I think, yeah, on a computer, maybe a way in Windows and Mac to do it without a special app. But yeah, definitely there have been some apps you can actually just flip the whole interface, the white menu bars and all that kind of stuff, the white cursor on Windows, to something that's not so bright and more of a red view. But it's nice that the apps have a toggle, and if they don't, leave them as is and put this on here. The only problem I found is occasionally, as I'll show you one of these apps, before I had apps that had the objects in the matrix where you could just keep zooming and see the actual pictures of things in situ, I'd have to go to a browser. Hey, let me show you what that object looks like. Get ready to ruin your night vision. And I would turn the phone down and I would show them the image so I can show the color of the image. The red obviously messes up your color of the image. So you'd have to have it in a way where you can peel back the red thing somehow, if you don't have a toggle that's easy to get to show a proper color image of something. Because sometimes people see the gray smudge in the telescope and they go, is that it? You go, yeah. And you can't blame the scope, and you can't blame anything else but your eye. It's your biology that's flawed. Because, you know, we're not nocturnal animals. We're diurnal, at best crepuscular animals. And at night, our night vision is terrible. You know, when you get the red eye in the flash on the camera, that's as good as we get. We don't have what's called the tapetum lucidum like nocturnal animals do have, like cats and owls and animals like that that are nocturnal, that have massive eyes with lots of rod cells in there, which is the black and white, very sensitive cells for night vision. And they have a reflective layer on their retina called the tapetum lucidum that allows the light to kind of bounce around the eye. It doesn't let the light just get absorbed randomly and not used correctly. The tapetum allows them to kind of capture more light when it's really faint, which is why their eyes glow so well when you hit them with the light. You get a similar effect with spiders and stuff too. It's pretty funny. Spiders have very reflective eyes. If you catch them at the right angle at night, you can actually look for spiders with a flashlight. Little glowing eyes. It's pretty funny. Anyway, so that we don't have that, and so you're at the mercy of bright images will give you color. So the planets are in color, and lots of stars are in color because they're very bright. But you look at a nebula, it's very bright, but it's still not bright enough. Or you look at a galaxy that's bright like Andromeda, it's still not bright enough. You need time exposures to capture those photons because there's not enough light for our cone cells, which are color based, to see the color. So that's why you have all the cool new fancy DSLRs and mirrorless cameras that have really nice sensitive digital imaging systems. And that's why I started the whole live stream thing, because I got the super fast f4 optics of the Newtonian scope, the astrograph, and I got a really nice super sensitive high ISO quality camera to capture images as quickly as possible in color. Now, if you saw my last stream, I still got some kinks to work out with focus and vignetting and all kinds of dumb things, but you know, it's a work in progress because I'm brand new to the imaging part of it. But it's getting better and better, and I can snap pictures of Andromeda Galaxy and Orion Nebula and other things in the future that will look really great. Saturn, you could see in the scope in the live view of the camera, and you could see that it was kind of a creamy yellow color. It wasn't white. Jupiter is generally pretty bright white with equatorial belts, a kind of rusty colored, brownish rusty color. And you can see the great red spot occasionally if you're lucky. But not a lot of color to see there in the view we have from here, unless you have a massive ground-based telescope and superior optics and filtering and stuff. So anyway, so it's nice to have that feature where you can pull the acetate off or turn the thing off to show a color screen quickly to somebody so they can see a color image, and then go back to letting them adjust their eyes again so they're dark adapted, because even a fairly bright fuzzy object in the scope, it takes you a while to get adapted to it. So once you look at a bright screen, you're like, oh, I gotta wait for a bit, I can't see what I need to see. So it's nice to have those options. So I was going to show you here. So one of the apps I was using is called Go Skywatch, and it had a clever interface because again they didn't have the images in the matrix that you could just pinch zoom and just find it the way it's supposed to be. So this Go Skywatch is pretty cool. This is the basic interface here. This one I think I have to turn up the brightness a little bit so you can see the features. There's a little circle in the middle there. That's your target. And it shows you some coordinates and a name and some other stuff. And as I move around, find an object. See that right there? So it's telling me how many light years it is from here, what the object name is, what it is, all that kind of stuff. So now I'm going to go into the deep sky objects, which are these little pink guys. And look at that. I got a nice picture as well as the object. Now I have to turn the brightness down a little bit because it's a little washed out. But if you go back to this guy again, so you already saw this earlier, this Andromeda Galaxy. Now it also happens to have M32 in there as well, so M31, M32. But it's telling you how many light years it is away, where the object is, where it is, all that kind of stuff. So easy to navigate really quickly. Here's the Milky Way. Here's another object. This is the Cocoon Nebula. This is what's called a planetary nebula. So as a star goes through its life cycle, burns through all of its fuel, fighting gravity, which is fueling the fusion in the first place, it eventually loses the fight with gravity, collapses. In the case of a really massive star, it can make a supernova from all that superheated collapsing. And you have something I'll show you later, the Crab Nebula, which was actually so bright in 1054 AD in China, even during the day, you could, or at least early part of the evening, you could see the brightness of the supernova as it was exploding. Now that was 1054 AD. The light took a while to get here, and it took a while to dissipate, and now it's just this kind of spidery-looking gray shell of which basically has, the supernova blows off its outer material, but there's always something left behind. In this case, it's a neutron star, a very massive, tiny little star that's often, I don't think it's always a pulsar, but quite often it's a pulsar. It's a rotating star that's actually sending out like a lighthouse, these beams along this axis. And so you can count the flashes of the pulsar, and people study that stuff and get all kinds of information from that. Our star is kind of unremarkable as far as being, showy. So when it basically collapses in roughly 5 billion years from running out of fuel, it's going to become a red giant, like Betelgeuse in Orion, and it's going to basically grow to the size of our orbit or Mars, roughly around there. That no one really knows 100%, but that's what they do. They swell up and take over entire orbits. And so, if we're still a species in 5 billion years, hopefully we've found another place to go by then with some kind of space travel. And then once the red giant kind of burns through its later parts of the periodic table, you've already gone through hydrogen, helium. Now you're doing, carbon and oxygen and all these other elements that are further down the periodic table. And then gravity wins again because it's now converted enough stuff to be weaker, and that collapses again. And as it collapses, it blows off a shell of gas all around, and that's what's called a planetary nebula. And in the middle of that is a white dwarf left behind. So it's not a neutron star, just a tiny little wimpy white dwarf. So that's what's going to happen to our sun eventually. And they're often very colorful and have structures. And one's called the Owl Nebula. It looks like two holes for like owls with big eyes and this big round face. So this app is pretty good because you can just go to an object if you're not sure what it is. Put it in the middle. Oh, okay, there it is. There's a star cluster there. All right. Some other objects here. So again, it gives you some little stats. Now the text is very small. Getting older, it's hard to read some of the stuff, but on the iPad it was great. It's a nice big interface, but I'm just showing you iPhone stuff right now because it's more convenient. But a lot of these apps run really well on the iPhone and much bigger, and sometimes have some more features and stuff. Anyway, so that's Go Skywatch, and it has some other cool features. You can go browse for the Jupiter's. Remember I said you couldn't see Jupiter's moons in some of these apps. You have to go to a little browser thing. So it'll show you Jupiter's moons and Saturn's moons, stuff like that. But you can't do it like right here. It's more basic. But the same company, if you're into satellites, also makes a thing called Go ISS Watch, and it's the International Space Station. And so just like you can find where the Starlink satellites are, and where the Iridium satellites are when they do flyovers, so you can see the glowing satellites flying overhead, especially at the right angle. When the sun hits it just right, sometimes they really pop. And they make a program called Go ISS Watch. And so now it's showing the International Space Station orbit. And if you zoom in, it will show you it's moving. So not visible from where we are, apparently. But what's cool is it'll not only show you where it is on the globe, up in the atmosphere, but it will give you alerts like, hey, at 9 p.m. today, or whatever, go outside and look this direction, you'll see it, and you'll see it looks like someone turned in a rheostat on as it appears at the right sun angle to get illuminated from our point of view. You'll see it just brighten up, and then as it just disappears from the view of the sun behind the Earth, but we can still see it up in the sky, it turns down. So you often don't see it go very far. You see it maybe go, I don't know, 20, 30, 40 degrees across the sky, maybe a little more, and then it turns down again like you just turned a rheostat down. I've seen it many times. It's pretty cool, actually. So the apps now will track it for you. There are websites that do it as well, but again, it's nice to have the app in your pocket. So that is the same company that makes Go Skywatch makes Go ISS Watch. And then another one of my favorite little apps, and again, it's basic now compared to stuff that's available, but I still like it. It's called Pocket Universe. I had it on my old iPad compact Pocket PC a long time ago, and now I have it on here. So you launch it, and it gives you a really basic interface. It's showing you a little graph of what's up now. So, or what's up today, with a little time graph and stuff. So it was showing earlier the moon was up, Saturn was up, and Jupiter was going to be up. In a nutshell. So the sky tonight, there you go. It's like quick news. And that's, now I can go to sky, and I get a nice little thing, and the constellations are turned on. This also has the crosshair thingy turned on, so as I move over an object, it lights up and gives me more details. In this case, it also gives me that little browser at the top with an image, similar to Go Skywatch, which is a slightly different interface. It's got the little buttons at the bottom, so you can go in here and go, what else we got? So now I'm in tracking mode. Just like all those other apps, I can track or turn that off. I had to click. So I like that. It's very quick if you want to turn that on and off very quickly. Then you have this time mode. So if you want to simulate sped up time, you want to see, oh, what happens in 3 hours from now, but I want to see it happen in a time-lapse format, or back in time, or like any one of these apps, you know, you can say, what was Galileo looking at on this given night? And you can actually simulate the night that he was actually, one of the nights he was probably drawing Saturn. And someone had a long time ago done this and told me about it. He says, yeah, I picked one of the nights he was most likely looking at Saturn in some month or whatever, and he didn't even know it, but Uranus was right next to it. So, because his optics weren't that great. Amazing for the time, but obviously not that great. And so, you know, to him with that scope, it would just look like a star, basically. But yeah, Uranus or Neptune in the same rough field of view that he would have been looking at. So that's, you can simulate historic events and what people should have seen, and it's fun. These apps are fun for all kinds of stuff, not just for looking at modern day stuff. So there's the simulator. And let's see, how do I get out of here? There's what did I do? Anyway, so you get the idea with that. There's the browser stuff in there. And what else did I have? So it's Pocket Universe, and then you get into the fancier stuff. This is the new stuff that I've been using a lot now. So I have Stellarium on the computer that I've been using on some of the streams, and I synced it with my scope, and you can see the scope's crosshair actively moving around, and I'm driving the scope from the software. I'm not even using the paddle, the little handbox controller. So one of those programs is called Stellarium. And I'll show you this first because I'm actually going to go briefly to Stellarium on the computer just to show you that they are basically the same. So here it's a nice, beautiful. The Milky Way is really nice in here. This one still has the constellations turned on and the shapes, so you can see, you know, what does Cygnus, the swan, look like. If you go over here, or is this is still up? Cygnus is one. So the head, tail, the wings. Northern Cross is the asterism, so it looks like the cross everyone's familiar with. It's the brightest portion of it, so it's Cygnus the swan with the wings and the head and the body and stuff. But Northern Cross is what people normally call it because they don't see all the shapes. And the Alberio, the eye of the swan, is very nice. Can I zoom in on this one and see it? I wonder. Will they let me? Yeah, look at that. It's going to break it up. So it's a binary star. And it's not quite showing the colors here very dramatically. But one is kind of a golden color, one is kind of a bluish purple color. More on the purple side. And again, everyone's eyesight is different. So when you do a group event, you can say, hey, what do you see? You don't tell them right ahead. You say, I see two stars there. What colors do you see? Just so they're not, their judgment isn't colored, no pun intended, by what you said. And that you can get a reading on what people are seeing, because everyone's perception is slightly different. They're not necessarily colorblind, they just see things a little bit differently. And another trick is in the scope. These are obviously sharp in here because it's a software, but in the real world you can defocus the object and the points of light become more like this kind of fat balls, like this kind of disc-like, and it does help you to see the color a little bit better when you defocus a little bit. So it's a trick, a little astronomy trick in the scope to help see the colors of some things. So here's an example of why this app is so cool. You can even zoom in on the double stars, you can zoom in on the planet Jupiter and see what the moons are doing right now. If you watched the other day, that stream I did from the park, just down the street here, I was actually able to zoom in. So I click on Jupiter, it tells me, hey, that's Jupiter. It gives you some stats, and I can read some stuff and look at a picture of it. But what's really fun is I can just do this. Actually, I don't have to click on it, it's just zoom. Zoom, 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 zoom. Now I'm starting to see the moons. Zoom, zoom, zoom. And there you go, all in a nice line, all the 4 Galilean moons. Callisto, Europa, Io, and Ganymede. Ganymede's the biggest one. Io's the one that's got the cool volcanic activity. Europa's the frozen world with all the cracks and stuff. And Callisto, I don't remember too much about that one, but they're all very cool and very photogenic. So, and you can zoom in further and further and further, and you can even see Io is showing color because it's the real data embedded in the software. Look at that. Ganymede is going to show real color. I lost it. Ganymede. Where's Ganymede? And you can even zoom in on Europa. Icy world, Europa. So, etc. And so this app is great because you don't need a browser. You don't need a window that shows you like the little dots in the layout like I used to have to use in some of these programs. You just zoom, zoom, zoom. Oh, okay, there we go. Cool. Now let's zoom back out. Back to the normal sky view. Same thing with Saturn is still up. Oh, the moon is still up too. I thought the moon had gone down already. So moon, you can go in and get some really nice detail on the moon. Not as good as that app I showed you. That was a moon browser, but you know, respectable considering it's built into the software here. And we'll also go look at Saturn. More information on Saturn, etc., etc. You know, if you want to, if you clicked it and it went off screen, you're like, hey, where the hell does Saturn go? And it goes back. And you zoom in, zoom in, zoom in, zoom in, and there's all kinds of Iapetus, Titan, Rhea, and a beautiful view of the planet with Cassini's division right there. A and B ring broken by Cassini's division. There's a C ring as well, but you know, but it's like, see these details here, like these belts of detail around the gas giant. This, you know, the outside of the planet is just a gas giant. You're not seeing any solid mass at all. But I've seen this kind of detail in a scope with my friends. Basically, $20,000 telescope. It was stunning. I mean, it looked like this pretty much in a scope. No photographs. We're looking at, in fact, a couple times we're looking at like actual, not just lines, but like texture. You can see texture to the clouds. It was crazy. You know, it's just a really good night, and he had the supreme optics. I mean, the eyepieces he was using alone, individually, were like $1,000 eyepieces or something more like that. And he was using a stereo binocular viewer, so he had paired optics. Man, was that cool. All right, so that's Stellarium. Now, real quick, I'm going to go to the PC version of it. Let me just enable it here. Actually, it's in the background. I just have to put it in the front. So now I've got Stellarium in the stream on the PC. Let's see, let me check the chat. I'm behind on chat again. Can I make this bigger? It's not big. Come on, man. Make it a little bit bigger. Zoom. Yes, thank you. Now I can read the chat better. Text was just too damn small. Sucks getting older. Let's see. Oh yeah, you said Iridium satellite. Yeah, Iridium satellites are very, very bright. So Iridium is a it's not just an element. It's also the name for a satellite system that was mainly aimed at rich fat cat executives who could afford the very expensive phones and pagers built on these Iridium satellite network. They're very low orbit satellites, and they allowed you to basically have a communication with anybody, anytime on the planet. You know, your provider, whether you got Verizon, Sprint, T-Mobile, and whether international carriers like NTT Docomo in Japan and all that kind of stuff, you have issues. You have regional problems, you have international problems with carriers, and just signal coverage in general. It's spotty all over the place. Even in a fairly urban area, you can have dropouts. Iridium was supposed to guarantee you're paying lots of money for this. You're going to be reachable anywhere. If you're like a fat cat executive or whatever, you need this. You're paying through the nose for it, but it works. Unfortunately, from what I heard, it was too expensive to maintain the network and not enough customers. And the satellites were only supposed to be guaranteed, because of the low orbit, only supposed to be guaranteed for so many years before they could just eventually burn up quicker than normal with satellites. Because, you know, I had a lot of space junk in orbit. I should have brought that up too. Next time I'll do a stream on that. There's a space junk simulator website, really cool. It tracks thousands of objects in orbit, and you can click on it just like I'm clicking on the satellites in these programs, and clicking on the planets and other stuff and zooming in. You can click on various pieces of space junk and tell you what it is, and you can track it. It's really cool, but it's also very sad because it's an example of just we have too much crap up there. A lot of it isn't even working anymore. And eventually it's going to burn up, but sometimes if it's big enough, it burns up and actually hits somebody or hits a house or whatever. So it's also going to create issues where now it's hazardous for certain things to be in orbit that can eventually collide with it because you can't control everything up there. So in the future, it's just going to get worse and worse with more junk up there. Yeah, you can actually track that stuff with some web apps and stuff. It's pretty funny. Anyway, I've seen iridium. They call it an iridium flare. So just like when the Hubble Space Telescope shows up, or the ISS shows up, and you use a tracker to find it appearing in your local view, comes into view like a rheostat, shines, and then fades out. Well, the iridium, you can't miss it because it's almost as bright as a very large airplane flying overhead on its way to your local airport. But instead of blinking lights, it's just a solid light, like a bright star, streaking across the sky pretty fast. And it also fades in and out, but it's really, you can't miss it when it's in the right angle. It's really, really bright. And there are, again, programs and software and web pages to track all this if you want to see it for your local viewpoint. So I recommend it if you can find a good time to see it. I haven't seen it for years, but I used to. There's always somebody at one of our star parties saying, "Okay, everybody, look at Sagittarius in the next 2 minutes." And everyone's like, where? Oh, it's almost like a meteor shower, but it's just a satellite going across the sky. It's pretty funny because it is impressive how bright it is. Massive solar panels for iridium, super reflective, and they catch the sunlight and it's just bam, it's unbelievable. Okay, so now we're in Stellarium on the computer. You can see I've turned a lot of stuff off in here because I was getting annoyed by the details, but it's essentially the same interface as what we're seeing in the on the app. In this one, they give you more information in this list because you have the space for it. So you click on the moon, it gets super nerdy. Look at all this tech information here, and you can zoom in further. Zoom. Again, same thing, just basic moon. Nothing too dramatic, unlike the other apps I was showing you. And then there's your general interface. And so for example, so I'll show you a couple of fun things here. There's the thing called the summer triangle. And because it's late now, the summer triangle is not as prevalent. It's basically an isosceles triangle. And you got Deneb and Cygnus the Swan, so there's the Northern Cross. You have Vega and Lyra the Lyre. It's like Greek harp, essentially. It looks like the state of California. It's got basically 6 major stars making this bend. And then you have Altair and Aquila the Eagle. And it's like a mini Orion. It's got 3 bright stars, but Altair's pretty bright in the middle. And there's the Eagle constellation formed out of it. I just turned off the boundaries, but you get the idea. And this is the summer triangle. So it's basically right above you in the middle of the night on a good clear summer night. So, and there's lots of cool objects in here. In the middle here, there's the Dumbbell Nebula, and over here off of Sagitta, there's Ring Nebula M27. Off here off of Sagitta, you have this is the arrow from Sagittarius that's kind of stray flying over here. There's a Dumbbell Nebula over here. Nothing too obvious in Aquila that I can remember. This little thing looks like a kite. It's like a diamond shape with the tail. This is Delphinus, the dolphin. All these names are all Latinized. So let's just show you the objects embedded. Look at this. I'm going to zoom in and zoom in and zoom in and zoom in and zoom in, and look what this guy is right here. This little dude right here, little dude. There's the Ring Nebula. It's like a little smoke ring in space. And because rotation's turned on, software is simulating everything. It's moving. And so this is a planetary nebula I described before. It's just like our star is eventually going to do after it goes through a red giant phase and drops back down again. There's a little white dwarf star in the middle there. And so that's Ring Nebula. Now, in the telescope, it's a ring. It's clearly a ring, but it's just gray. It's not colorful. So I was trying to image this real quickly on Sunday morning up at Glacier Point. But I realized, you know what, time was running out as I got a late start, so I went straight to the bright stuff. I went to Andromeda, I went to Orion Nebula, and a couple other things. But I was trying, first I tried this, and I thought, nah, it's not that bright, and it's kind of small. So I will eventually go back to that on a stream, because it's a nice object. M27. And if I want to go to, let's go to, where did I go? Zoomed in too much, there we go. So I have the summer triangle again. Come on, there we go. Zoom out a little bit more, there's Deneb. So if I go to Sagitta, zoom in, this is what's called star hopping. So once you learn the basic patterns of the sky and the little constellations and stuff near the constellations, you can just star hop. So I'm going to zoom in and zoom in and zoom in. That's actually North American Nebula. That's really cool. But I'm trying to find the one that's really bright that people know very well. So it's right around here. I thought it was off of Sagitta. Hold on. Am I going crazy? There it is. Oh boy. My star hopping is a little rusty. I thought it was right off of Sagitta. Or is it on the other side? Showing my rust here. That was between those two stars of Sagitta. Interesting. Well, since it showed up in the matrix, let's zoom in on the North American Nebula. It's kind of crude. You can see it's like this square that they kind of pasted in the interface, but hey, it looks cool though. Let me just, why is it not selecting? There we go. It's supposed to select the object. It's only picking stars, but I was hoping it would find the object itself and give me the name. It's called the nerdy star names, but interesting. Well, that's what's cool about the software. You know, even if you don't know what you're looking at, you can zoom in and go, well, that's a cool object. You're not going to see it like that because it's colorful. But I'm kind of bummed I can't find M27, the Dumbbell Nebula. I'm out of it. I should see it now. I'm zoomed way in. It's actually a pretty big, bright object, but I feel very silly for not being able to find it from star hopping. But anyway, that's kind of this fun stuff you can do with the software. Jump around. So again, summer triangle. You want to find the North Star. I showed you in the other app. So you go outside, you're like, okay, where is north? Well, here it's telling you because it's a cheat. But how do you find north? Where am I going? What's happening? So if you zoom in, you're like, well, if you use a compass, it'll give you magnetic north, which is close. But this is closer to true north. And this is Polaris. Polaris has been North Star for a long time, will be for a long time. The funny thing is proper motion of the stars, you know, because we're getting a vantage point of the stars, but they all have their own proper motion. They're all going different directions based on expansion of the universe, and so in a 3D simulator, it's really fun to watch because they'll show in 1,000 years what the constellation will look like, and another 1,000 years stars, and you'll see eventually the Big Dipper is going to be the big plow. So let me find Big Dipper here for you. Big Dipper is this Cassiopeia, M or W based on your orientation. There's Perseus. It's like the Greek letter pi kind of stretched out. And if you want to see stuff totally enabled, I can turn on the constellations, I can turn on the artwork, or the names, I can turn on the artwork, I can turn on the constellation boundaries. There's all the boxes that determine it. So there's Cassiopeia, she's sitting in her throne. It's really just this little M shape, but you know, it looks like somebody's sitting in a throne apparently. Cepheus looks like a house upside down. I always think Cepheus looks funny, but here it's a guy, and why the point is down, I have no idea. And as you can see, I mentioned earlier, oh, here's Perseus, so you can see him standing here. And then there's the giraffe, Camelopardalis, which is basically a triangle with a line. That's the giraffe. There's all kinds of fun stuff, but I like, this is a good one here, is you have, I was talking earlier about Pegasus. Here's the Great Square of Pegasus. So here's the square. Here's the head, here are the legs here, there's legs going that way. And this back leg basically crashes into Andromeda, so it really doesn't have a back leg according to the artwork here. And Andromeda, you follow this down, boom, boom. You have this branch right here of Andromeda, and look what's going to show up. You zoom in, and you zoom in, and you zoom in, and it's already showing itself, the Andromeda Galaxy. And you zoom in further. There's a beautiful shot of all the dust lanes of the spiral galaxy. M31, M32 next door, and NGC 205. And if you want to know, you just click them. Also called M110 because Charles Messier was a comet hunter, and he was just cataloging all the fixed objects in the sky because they're not going anywhere. Because he's looking for these same kind of fuzzy objects that are moving comets. So he made a Messier catalog. It was like, I think it went up to like 80 objects, 80, 90 objects. And then people glommed onto the list thinking, oh, this is great. This is objects for amateur telescopes. We need to use these to show people, and you know, it's great teaching aids, and also all these different types of objects, not just galaxies and stuff. So, but people kept finding other objects they really liked, and so they basically artificially added objects to Messier's list long after he was dead. And so now M110, I think, is the last one that was added. There might be a few more afterward, but last one I knew of was M110. But normally is known as NGC 205. New General Catalog. There's the it's just Bayer, I think his name was Bayer. Catalog, the New General Catalog a long time ago. But see the other catalogs. There's a UGC and a PGC and the NGC and the M. There's also the Caldwell objects. The guy from Astronomy magazine kind of came up with his own list of C objects, Caldwell objects. But they're basically Messier objects or NGC objects, kind of rebranded. But yeah, see all this stuff, and because it's tracking real time, all these numbers are changing because stuff's moving across the sky because of our orbit, and things also have their own values in their own right. So, pretty interesting. I want to get nerdy about this stuff. So, click on, does it even click on M31? It's so big, I'm not able to select it. You have to probably do it when it's smaller. Nope. Nope. Maybe the middle? There you go. Click on the nucleus, you get the Andromeda Galaxy. But in the scope, you're basically seeing like this, the nucleus and a little bit beyond. So if you watch my live stream, I'm getting, my picture's getting about this much of it, because you need a longer exposure to get the whole damn thing. Pretty wispy, but I did get at least one of these dust lanes in my shot, which is cool. It's dust blocking stuff. So there's the M32 and NGC 205. Hey Prometheus, how's it going? Yeah, this is some space ambient music I yanked off of YouTube. I'm sure I'll get a copyright claim, which is fine, just as long as I don't get a copyright strike. I don't care. Anyway, so that's how you find some objects in here. You hop around, it's star hopping, so the Great Square Pegasus, go down one, down another, now you're in Andromeda, and then you just got 3 stars here, and the dude's right off here, Andromeda Galaxy and the other companions. And as a comparison, you can use Cassiopeia as an arrow. So the top of the M here goes there, and this comes down here and arcs out, and you go choo-choo-choo, and locate your galaxy right there. So if you stare at this naked eye, when you guys get a chance to get a clear sky, if you at least remember Cassiopeia, you can find it. Just go straight out, and you'll see a big fuzzy thing right about here. But definitely try to find the Great Square Pegasus, which is pretty big and bright. And as you follow it down and go across, triangulate your view, you'll be able to see Andromeda naked eye, or at least use binoculars. You can carry binoculars. That's another thing I was going to talk about, is viewing tools. I'll just start doing that now. I've been carrying these binoculars around since about 2000 when I went to Japan. Let me go to back to my camera view. And Pentax 9x25. You know, this little thing, they separate. Comes a little carrying case. They were like, I don't know, $200 back then, but I've had them since 2000, and they still work beautifully. And they just, a little carrying case fits in your pocket. They even keep a little thermometer compass thing with it. Just take it everywhere. So it's good to go out sometimes when you can't see something naked eye, but you know it's there. Use binoculars, it'll help you find stuff. These are not super light gathering because they're only 25mm objectives. So you get a 9x35, 9x something or other, or 10x50s are really nice, a little bit bigger, but they're really good for astronomy. Just take them everywhere. You can use them for birds, you can use them for astronomy, whatever you want to do. If you have access to a scope, if you're into birding, and you have like the spotting scope with a zoom eyepiece built in and a decent objective, this is like a 50mm or something like that, and a focus thingy here. This is a Bushnell, just a basic Bushnell spotting scope. Optics aren't ideal for astronomy, but they're good enough for the planets, the moon, finding some stars here and there. If you get into it, you can buy these attachments. Put the eyepiece in here, clamp down on this, put your phone right here in this little bracket, and adjust this and slide it up and down, and you get your little eyepiece and the phone. Right on top of the thing, you have to match the exit pupil of the eyepiece. And yeah, it's trial and error. Once you get it, you just lock this thing at the right angle, leave it that way, and every time you slide your phone in there and put this on the thing, it'll perfectly be lined up. You don't have to keep resetting it. You just have to tighten it once in a while. Another thing to do is, if you're going to use your phone not just for astronomy apps, but camera, to take pictures of the Milky Way or time-lapse to get star trails, if you leave the shutter open for 15-20 seconds, sometimes 2 minutes, the sky will still be pretty dark, not all washed out, and you get these nice little star trails going across the sky. Like when you leave the shutter open and you get satellites going across your image. But the stars will actually trail. And if you aim at Polaris, you get this awesome star trails in a circle because you're at the pole. So that's also fun. And in order to make it easier to do your photography on the go, you have your phone, you get a little portable tripod like this made by Joe B. And it's called the Grip Tight 1. Sounds like another kind of product, but it's these are like, I don't know, $35 or something like that. Sounds expensive, but look at this. It's the smallest full tripod system for your phone you can get. Is a little mini ball head here in the tripod legs. You pull these out, got a little tripod, and it swivels. The whole thing basically is on a mini ball that's pretty tight. And then you pop these, you pull this up, you pop these open, put your camera in there, and then you have a little tripod, and you can pose it however you want. So and if you do time-lapse shots, or you do open shutter shots, there's all kinds of stuff, and it just fits in your pocket, closes back up. If you wanted to use this bracket on a real tripod, you can just unscrew this and use the bracket itself with another tripod. But I love this as a full system that just goes right in your pocket. Very clever. And while I'm thinking about it, let me... Oh, you know, am I covering up my app? I think I am. That was silly. Let me do that all over again. Sorry, I forgot I changed the view order. I should be monitoring OBS better. Let's change the view order of this guy again. View order. Move up. There we go. Instant replay. Binoculars from Japan. 9x25s. Very nice. Very portable. Had them for decades, and they still work great. You even carry a little magnet, thermometer, compass thingy on there, so I can take it anywhere. If you have a spotting scope or some other kind of thing, binoculars, you want to use one of the eyepieces, you can attach. This one has a zoom eyepiece on it for bird watching and stuff. But it's okay as a poor man's telescope for when you're in a pinch. It's got a nice 50mm objective, and then you can attach a camera bracket to it. And this, just unscrew this, clamp this down on your eyepiece. Once that's locked in, you put your phone in here. You have to unscrew it to make it open up, but you put your phone inside this bracket, and then you unlock this thing, and you slide it around into the eyepiece, and the camera of the phone matches there. Get a perfect exit pupil match, and you can lock it down, and it's just set and forget. And all you have to do in the future is just unlock this and slide it back on when you need to use it. This one's a metal one, but you can buy plastic versions on Amazon, and even smaller stuff than this. I just like this because it's very professional, very sturdy. It's only about 20-30 bucks or something like that. It wasn't bad. So you have that. And then I was talking about tripods. So Joby makes this. Joby's famous for the Gorilla Pod thing, which has all the rubber flexible legs that look like balls. And they're fun for gripping around trees and all kinds of putting on a fence. But they make this little thing called the Grip Tight One. Again, a funny name. And it's a tripod and a camera thingy in one. So it's just screwed in here, but you can see the legs pop out on a nice little tripod. And then this pivots on the little ball head that's in here. And, so there's the pivot here. Pop these open. Put your camera in there. Put it on the ground or the rock or whatever you are, and just pivot it around. And this is a pretty sturdy little ball. It'll lock in place. You don't have to tighten it, but there's a way to tighten it if you need to. The camera goes in there, and you can take time-lapse shots and open the shutter for star trails. Like I was saying, if you aim your camera at the North Pole, the Polaris star, you get star trails in a circle because you're at the pole. So that's also very fun. And before I go back to the astronomy app real quick, on the desktop, I will show you a couple apps I recommend for photography on your phone. So, DSLR camera allows you to, now it's an auto, but I can do full manual, change the ISO, the shutter speed, the focus manually with the focus. And what's really cool on a newer iPhone that has multiple lenses, it's wide, super wide, and normal, you can actually see them right down here. This little square. And it'll tell you on the screen what it's doing. I click on it. Now I'm in the auto. Now I'm in the telecamera. Now I'm in the wide camera. Now I'm in the ultra wide camera. And a little graphic changes to show me which shape on the, so you can know which one you're actually clicking on. So I actually didn't know which was which because I haven't read the manual on this thing. But now I already know which lens does what based on this camera app, which is very clever. And there's also video mode, so you can do it in video as well. Full control over your stuff. So you do filmmaking stuff and you want full control of your aperture, your shutter speed, your ISO, manual focus, all that kind of stuff you can do with this app. Not very expensive, really, really cool. I have other apps I use for video. One's called Mavis, which is really good. I use it for all the hardware jam stuff I shoot. But this app is great for photography or video and full control over. And the problem is when you put this in auto over the eyepiece of a telescope, whatever, it gets confused because it's trying to do everything auto. So if you lock it into one of the lenses, it would just stay where it's supposed to be, and you play with the focus and get the bracket lined up with the exit pupil just right, and then you can get really amazing shots. It's called digiscoping. We either hold it in front of the lens or you actually put a bracket on it. It's also called it's not antifocal. There's another technical term for the thing somebody used online, but I always called it digiscoping. That's what most of the community calls it, because your digital camera over your scope, and it's kind of a cheat, kind of a shortcut. It's just called digiscoping. So that's the DSLR type app. If you're doing special effects stuff, there's a really fun one called what do you call it here? Not now. It's called slow shutter. I've been using this for a long time, since an older iPhone. And pretty basic interface, but all these things you can change the how long the shutter stays open with like a bulb type setting. It has is it done? There's some really basic settings here for like blurs and trails and stuff, so you can get, like, as people walk by, you get like these ghost images blurring together, or cars with headlights making blurry lines, very artistic kind of stuff. And then you just, you have your app, and then you just take a picture, and it stays open for as long as you told it to. I just slowly moved it, and now you get a preview of it, but you can also go look at the picture as it is. And you can edit it on the fly too. If you don't like what it did, you can go post-process it inside the app and adjust some sliders, because it's doing stuff in layers, which is pretty cool. So, slow shutter, fun little app. So that's some basic photography stuff. If you're into this thing, got the brackets I showed you. You got the binoculars. This one you can't attach a camera to really, but a proper binoculars that has an eyepiece that you can attach to, like this spotting scope. Take one of the eyepieces on your binoculars. You can use that as a camera lens. Poor man's camera lens. So that is the thing. So I kind of jumped ahead. I was going to do that toward the end, but it's fine because the topic already came up. So what else are we doing here? Oh yeah. So I'm on the last several apps of the thing. Let's go back to the Stellarium again for a little bit. Let's put that one on top. I forgot to do that before with the camera. Okay. Check the chat. You guys got any comments or questions here? Yeah, webcam's pretty good. Even the old crappy, like, what was that company that made webcams for a while? Connectix webcams. And Logitech, of course, has webcams. And so webcams, even the old really bad webcams. I saw a guy who took a picture of Jupiter with a webcam. He basically taped it to his telescope, kind of, I guess, the digiscope style. And he took, I don't know, 50 images of Jupiter, all really bad. but still kind of look like Jupiter. And he ran it through this. There's a bunch of programs you can use now. One's called Redshift, and it basically takes 50 images, stacks them, and additively adds details after it's aligned, all the stuff that's missing. And with this composite image, you got stunning pictures of Jupiter with a really crappy webcam and stacking images. There's some other programs now that make it so automated, you don't even have to worry about it. You can just basically shoot a video, convert the video to an AVI, run this AVI through a stacking tool, and it will take thousands of images. You can say, take the best 25% or whatever, and stack it for me. And you tell it, hey, this is, by the way, this is a planet, so it kind of knows what it's looking for, shapes and stuff. And it will do all this crap for you. So I'm actually, I didn't realize this stuff now was so easy and so quick. I thought it used to take a long time to do this stuff. So in a future stream, I'm actually going to do some stacking with my DSLR on the fly, because it is a very quick process nowadays. So you guys can see, instead of just a live view of Jupiter or Saturn, or a live view, you know, of some of the other stuff, or even a single shot, slight time exposure of a nebula or a galaxy or something. Once I get a few decent shots on the stream, I might do a couple Redshift kind of stream shots. Because you only have to wait about, I think about some of these, like, you shoot a very short AVI of like a couple hundred frames, and it processes the damn thing in like a minute or two. And then you get these beautiful images. So I'm tempted to try that, because it's quick enough to do on the live stream. So good stuff, good stuff. So where's it going to go next? Let's go back to the software, I think, just for a little bit more. Make sure it's on the top. Okay, it is on the top. Good. So I've shown you Andromeda, Pegasus, kind of star hopping around. Good to learn the sky to a certain extent. Not that you have to, but the more you do, the easier it is to find stuff, especially if you're trying to share it with people. So I'll leave the constellation boundaries on, and we're going to go to the front. Sorry, wrong direction. Should have gone over here. There we go. So you guys can probably already see it, because I have it pretty much cut off the right of way, but there's your Big Dipper right there. One of the handle stars is down, but it's 3 in the handle, 4 in the bowl. And as Polaris rotates, as basically the Earth rotates and our vantage point changes, the ball appears to basically look like it goes up and it looks like it's going to pour out, because it's rotating around Polaris. So an easy way to find the North Star, if you can find at least a piece of the Big Dipper, the obvious section here, is these 2 bowl stars on the end here form a straight line that goes right to Polaris. And there's the Little Dipper. So they actually kind of pour into each other. This one's upside down, so it's pouring. When this one's upside down, it's pouring into this one. So it helps you remember the orientation and how to find Polaris. If you have a telescope you're setting up that has an equatorial mount, or you know, some kind of a mount you want at least roughly polar align, you got to know where Polaris is. So, and even if you're not into telescopes, but you're out on a hike and you're lost, and there's no moon, there's no sun, it's nighttime, you don't know where north is, you don't know where anything is, you have Polaris. You find Polaris by finding the Big Dipper and going whoosh, straight up to Polaris. And then there's all kinds of other cool stuff you can find once you've found Polaris, and how to get around the major objects in the sky. It's late now, so for this time of year, where the Big Dipper is at this angle, this time of day, so you can't see it. But another fun one you can use is this arc of the handle, turn off the supposed to be a way to. Oh, that's nice. Turn on some more features here. So this is you can turn on the haze, so you see less stuff, or you turn it on and just get more stars. This was like when you go to Yosemite. It's like the haze is gone, stars like you can't believe, and if you're not used to it, you go up there, you get lost for a few minutes. You're like, oh my god, where are all the constellations? There's so many stars. But it's kind of nice to have it so you can learn them. Turn this off, turn off the haze. I'll turn on the deep sky objects now. There's the pinwheel galaxy. This is a nice one. There's a lot of galaxies around Big Dipper, Ursa Major. And they're often companions, which is really nice. So we go here. Look at all these guys together. There's the pinwheel galaxy. This is M101. Nice face-on spiral. Beautiful. And they classify spiral galaxies. SA, SB, SC. It's like the tightness of the. If it's a barred spiral, there's a B in there. You see like a bar going across. And then there's ABC is the tightness of the rings. And it's just a really beautiful object. And this one looks like almost this good in the scope. You don't get the color, you don't get as much detail, but you can see the structure. It's really, really cool. It's a big object too. And not too far from it is some other galaxies around here, but there's M101, M102, and where's M102? I forgot which direction it's in. It's nearby. I know that. It's M102. Been a while since I looked at it, so I'm kind of forgetting the distances here, but really nice are M81, M82 out here. Not there. Not there. I went too far out. Over here. M81, M82. There. It's M81, M82. So, Boda's galaxy, the Great Spiral. So again, it's almost face on, a little bit edge on. Nice tight spiral. And then this one next to it is cool. Cigar Galaxy, also called M82. And you can get them in the same field of view in a telescope. So you can see this guy right down here, big, and you're probably seeing about this much in the telescope. Mostly the nucleus, a little bit of the spiral area. But this one's clearly like a broken cigar. It's really funny on the scope. So I like those a lot. So this time of year, a little earlier in the night when it's not so late, not so low on the horizon, it's nice to look at M81, M82. And there's all kinds of other stuff too. Let's look down here is the Owl Nebula. I think it's just below the horizon. I can't remember looking at M102 Anyway, so here's a barred spiral. See the nice bar going across there, opening the spiral. I don't remember looking at M109 before. Probably have, I just don't remember. But there's other stuff around too. The L Nebula, which is right here. Another planetary nebula. See, it's a big round face with big eyes. It's called the L Nebula. And again, that's gray in the telescope. It's not blue like this. But really cool. There's one called the Saturn Nebula. It looks like Saturn, even though it's a planetary nebula. There's a really nice galaxy here. I haven't heard it called the Surfboard Galaxy. That's a good name for it. I've seen this one before, though. Again, it's like a cigar. Lots of dust lanes in it. So, yeah, lots of stuff here. Big Dipper is famous for its look. Everyone knows the constellation. It's actually asterism inside the constellation Ursa Major. Because you can see the rest of it there. There's the head of the bear, the front legs, the tail. But it's a funny thing about the Native American version of they also call it the Big Bear. But because Native Americans pay a little more attention to nature than some people do, they didn't make this long ass thing the tail, because bears don't have long tails. They have a tiny little tail. So what they called this is the bear being chased by the three braves, hunting it. And the really funny thing here is Mizar in the middle is the brave holding the cooking pot because they're going to cook the bear because it's a double star. Look at that. Alcor is the little companion. And in the old days, oh, look at the satellites going by. Which satellite is that? Oh, it's one of the Starlinks. Elon Musk, damn you. Anyway, so Alcor and Mizar are famous binary star system. And separation is just enough where they used to be used as a test of eyesight. It's really easy to see, actually, but I guess maybe back then some people had pretty bad eyesight or something. I don't know what the deal is, but that was a story I heard about it was like an old school military test for your eyesight. Can you see two stars there? Then your eyes are pretty good. But I like the story about the Native Americans where it's three braves, but this one's carrying the cooking pot because he's got a companion there. So it's pretty funny. So yeah, I love Ursa Major this time of year. The Summer Triangle stuff is great. Ursa Major is great. Hercules is really good. Here's Hercules. It's basically this trapezoid and arms and legs here. In fact, I want to see. I forgot where his body is here. Okay. Yeah, so his arms are up. One arm's up, one arm's down. It's like he's flailing his arms, I guess. And then the rest of him's down there. So basically under his left armpit, or is it right armpit? Let me see. Oh, he's fighting a serpent, according to this. Interesting. Well, under one of his armpits, you can't tell the angle here. Right here, and this is an easy one to star hop to as well, is the wonderful globular cluster called M13, and it's a binocular object in a good sky, just to see a fuzzy star. Really, it's very, very big and very cool. But wait till you see this. Check this out. And this one in the scope looks just about as good as this. You just don't have the color, and you don't have maybe as much detail. But beautiful big ball of stars. Like you don't see all these colors necessarily. It's more kind of uniform because this is a time exposure. But it looks like diamonds on black velvet. Just a pile of diamonds. It's beautiful. So that's M13, the Great Globular Cluster in Hercules. Globular clusters are interesting. They're made of very old stars, tightly bound together, and they're generally in the halo of galaxies. So when you get a nice view of a galaxy, say, well, either an elliptical galaxy or even a spiral galaxy, and you get an edge-on view, and the bulge, the galactic bulge, up above and below the plane of the galaxy, you see globular clusters in a halo around that galaxy. They're very old objects, and they're generally found in the outskirts of the galaxy. So there's actually some really great shots of other galaxies with globular clusters in the halo. So I think it's M87 in Virgo. I have to double check, I forgot. And you can see these little dots, and it's so cool to see globular clusters in another galaxy, because as you may not know, everything you're seeing here, other than galaxies and quasars, if you can find one, and certain other unique structures, everything is in our galaxy. All of these stars you're seeing are all inside of our galaxy, the Milky Way. So when you see a globular cluster in another galaxy, that's pretty cool. Because that's, I don't think many of them image that well in other galaxies. Certain ones are very distinct. But yeah, everything you're looking at, that's another thing to put you in your place there. A galaxy is clearly a separate, as Carl Sagan would say, billions and millions of stars, just like our galaxy is. And everything in between is, a lot of perceived empty space, except for dark matter and dust and other kinds of whatever's out there. They're still figuring out. But basically large, dark voids between the galaxies, because everything's gravitationally bound into galaxies. And then you have clusters. So you have clusters of stars, clusters of galaxies, and superclusters of galaxies. And if you zoom, there's some other programs that you see, kind of like the exoplanet program I showed you, but there's some that really concentrate on the galaxy clusters themselves. And there's certain formation names as you get further out, this large scale of the universe, and they're entire voids where there's no perceivable galaxy, even in the superclusters of galaxies. This is huge voids. And one of the fun things about the Hubble Deep Field image, it was taken many years ago. At the time, it was the most expensive photograph ever taken. It was like, I don't know how many days and days and days of images, which in scope time is very expensive. They usually do like hours at a time, but they had like many, many, many days or weeks of imaging to capture these, a really uninteresting part of the sky from what we thought as the people were studying it. And I think it was somewhere near Pegasus, and they basically took the equivalent of 2 pins that you would sew with, sewing needles or pins you would use for sewing, at arm's length as a cross, and the junction of those. They basically took an area that size in the most uninteresting part of the sky from all the sky surveys they had done before. And the Hubble Deep Field studied that for days and days and days, probably weeks and weeks and weeks. It took this massive long exposure and composite image, and they came up with 10,000 galaxies they've never seen before. And the image is cool. If you look it up as a Hubble Deep Field, there are basically a whole bunch of stuff that look like giant fuzzy stars, and some look kind of like galaxies. But there are only like 3 or 4 actual stars in the entire image. Maybe a couple more. Everything else is a galaxy. So the picture you see, you're not going to see 10,000 objects. This is a condensed view of it, so they can show it. But when they zoomed in and blew up the image and studied them, they found 10,000 galaxies in an area they had never seen any galaxies before in the sky. And Hubble Deep Field was crazy. And this is, it's already 5 or 6 years ago, or whatever it is. It's a long time ago. And they had already found all that. So who knows what they found lately. I haven't kept up with all that stuff, but really puts you in your place and shows you the structure of the universe that we thought we had. All these like the Virgo supercluster and this cluster, that cluster, and it's like there's tons of the stuff out there. and with statistically, with biology as you understand it, chemistry as you understand it, that the physics principles of physics in the universe in general, and the amount of stars and double stars and galaxies out there, the fact that there would be no other life out there is pretty ridiculous. What form it is, if it's carbon-based, silicon-based, nobody knows, but there's got to be some other stuff out there. And they're definitely not coming here and putting probes in hillbillies' butts, I'll tell you that. So, and flying in little tic tacs around our planet. So it's just funny stuff lately. All this UFO, UAP, whatever they call it. So I'll show you a couple more things. So what I was going to show you here, because it's below, and I forgot how to turn off the horizon. There's a quick way to turn off the Earth blocking horizon to show what's below, but there's a little trick you can use. A few major stars in the sky, if you take this arc and it arcs down to the planet, to the star Arcturus. Where's my little search thing? One of these is... if I could just point to it. Somewhere I don't want it to go. There's red display, so there's your night vision stuff. That's full screen, which I didn't want. What is this? Full screen, no. Text is so small. There we go, just to find. Why is it doing this? Let's just zoom in real quick because I can't. The text is so small. I'm having trouble reading this here. That's meteor showers. I don't want to look at meteor showers. There's a quick way to turn off the, oh, you can turn exoplanets on. Not that you would ever see them, but you can turn them on. Oh, great. This Stellarium has a bug. When, I found this on the stream one night. When you do it as a window and not full screen, sometimes you click a certain part of the interface, it thinks you click the X to close it, which is really a bad bug. So, it just quit on me, so I'm just firing it up again here. I'll just show a few more things in the app because it's easier on here than on the phone, and then I'll switch back to a couple more phone things. So I'm getting a little tired here. I gotta call the stream in a bit. Still recovering from crazy weekend in Yosemite. Driving endlessly yesterday. Okay, let's minimize this again. Hope it doesn't crash. Let's what's this? So there's satellites you can toggle on and off. You can turn on quasars, you can turn on pulsars, you can turn on there's a telescope control stuff that I use. Here's the speed. You can show. What is this? Satellites. So I can turn the satellites on and off. You already saw some satellites moving earlier. So you can change time here. This is your time machine controls. And that's quit. I don't want to hit quit because it already quit on me before. There's some other settings up here too. You can tweak a few things. Like you can turn on a telrad, which is the, as I was showing in the other app, this is A field of view you would have in your telescope, you can change the shape of the field of view. You can turn on, what's this? Oh. Yeah, ocular view, if you have your telescope parameters put in here, you can change them. There's the Telrad view. So I use a little laser pointer thingy that's like a Telrad. This is more of a bullseye thing you can have projected. When you look through this little thing, it perceives to project it on the sky. So you can just star hop, like, oh, I'm going to go right to this guy. And then go hit go, and then your telescope follows it right to that spot. It's really cool. I'll turn the Telrad off. Anyway, I was going to show before was for the program crashed. No, not the shapes, just the lines. There we go. So in a different time of year when these other stars are up, here's the Big Dipper starting to go down here. You can use the arc of the handle and arc to the star called Arcturus. It's like a mnemonic device. You arc to Arcturus, and then you go straight to Spica, which is in Virgo. So Arcturus is in OT is the herdsman, and Spica is in Virgo, the zodiacal constellation. So you can learn to navigate a whole section of the sky from just the Big Dipper arcing over to two other stars. And then you have the summer triangle, which I showed you guys on the other app. And then you have other major landmarks and stuff to jump around. You got Square Pegasus, you have the Cassiopeia, the W or M, depending on your angle. And Perseus, which kind of looks like the Greek letter pi stretched out. Cepheus is the house. Has a house shape. There's Cygnus, the swan. So here's your summer triangle still here. Deneb, Vega, and Altair from these three different constellations. There's all kinds of stuff here. There's the Vulpecula, the little fox. Like Vulpes is the genus for red fox, so Vulpecula is the little fox. Sagittarius, a stray arrow from Sagittarius just flying through here. Delphinus is the dolphin. This one's hilarious. It's like a little trapezoid. It's called the little horse, Aquilius, little horse. So the people are pretty nuts who made up these. This is Lacerta, the lizard. There's some pretty ridiculous constellations. Down the southern sky, they really ran out of ideas. There's Microscopium, Telescopium. There's a really cool one though. It used to be Argo Navis. It was the Argo from Jason and the Argonauts. And they decided instead of calling it Argo Navis, let's break it up into chunks. It's easier to remember. So they have Puppis, which is the sail, Pixis, which is the compass, Carina, which is the keel. So yeah, there's all kinds of funny stuff down there. This is Cetus, the whale. So here's the body, and here's the tail. Well, in this case, the flukes, because cetaceans have flukes, not tails. Auriga, the charioteer. And here's Orion. Everyone knows Orion. He's either a sword or a club, depending on what you're looking at. And he's got this shield, or some people have said it's a bow. And he's walking along with his little hunting dogs, Canis Major, Canis Minor. Canis Major has Sirius, the brightest star in the sky other than the sun. And the three stars at the belt. And if you zoom in at the scabbard, where the sword would go, assuming that's supposed to be a sword, I guess, you can see the embedded objects here. I was doing pictures of this up at Glacier Point. And if you zoom in and zoom in and zoom in and zoom in, you'll see the center of it is the trapezium, which in general is 4 major stars, but I've seen up to 6 before in good conditions. this is a big stellar nursery, and there's a really cool structure here and colors. And one of my favorites though was up here off the belt, which is very hard to see. The Horsehead Nebula. Look at this thing. Beautiful. It's basically I forgot if it's an absorption nebula over, like a dark nebula over an emission nebula, or if it's a dust cloud over. But it's this beautiful, like the chess piece. Nice horse head there. And there's some other objects around here that you can see. But this one's really hard to see. I don't know anyone who's seen it visually, even in the best conditions ever. You need to have some kind of photographic help. There's some filters that are supposed to help you find it, because it's using hydrogen beta light, a certain wavelength of hydrogen. There's hydrogen alpha we use to look at the sun and some other stuff. We filter out just the specific wavelengths of light, a certain amount of angstroms. And then supposedly H beta helps you resolve the horse head a little bit. But I've never talked to anyone who's actually seen it. I don't think. By these filters, H alpha O3 is doubly ionized oxygen for looking at certain kinds of nebulae. H beta, some kinds of other funny filters you can buy. Like any hobby, has tons of stuff to spend money on. Here's one of these zodiacal constellations, Gemini. So Castor and Pollux. See that they're arm in arm, and their little legs and stuff, and their heads. It's Castor and Pollux. So yeah, there's Taurus the bull. So it's this whole structure. There's the bull's head and the horns, and then the body's out this way. This one also has a couple asterisms inside of it. There's the Hyades, which is this V-shaped structure with all kinds of stars through it, making a nice, really large star cluster called the Hyades. So there's that, and then up here you have the Pleiades, which I actually showed on one of my early streams when I first got my scope using the iPhone. And it's the seven sisters in Greek mythology. So there's 7 bright stars here, along with a bunch of other stars. And all this nebulosity, because it's also a stellar nursery. Gas and dust coalescing into stars. Gravity. And here you can actually see the names of them. So, all kinds of cool stuff around here. So, you learn the zodiac. If you are into astrology at all, or you just read the newspaper, and you'll see the order is correct for the Gemini, Taurus, Pisces, etc., etc. But it's funny because, like I was saying before, the ecliptic, where the plane of our solar system, which is where the planets are found here, so Jupiter, it also goes along the zodiac, which is why there's the Jupiter's in the house of Gemini or something like that. But because of our viewpoint of the universe shifts as we have wobbles in our orbit and precession of the axis, and other things going on, and even proper motion of the stars over time, you're not always going to have planets hitting the zodiac exactly. It's going to go into nearby. Like, I think a couple times there's a constellation Ophiuchus, and a couple times planets have been in Ophiuchus when astrologers are claiming, no, it's in this constellation. It's like, go out and look, it's right here. It's not there at all. Your astrology is based on several hundred-year-old information, and things change. Yet they're still claiming the planets have control over your life and your destiny. So whatever. It's a whole other matter. I wonder if they have this one really cool structure here. Let's check it out. It's a famous, really difficult cluster of galaxies called Stephan's Quintet. It's 5 galaxies, and it's in Pegasus. I always forget where it is. thought it might show up on here. Don't see it popping out. It is pretty faint, so that may not have made it a prime object. Oh, wait a minute. What's this? What is this? It's not selecting whatever it is. Oh, there we go. Just the stars. Did I turn off the deep sky stuff? I turned them off, that's why. So, do we have Stephan's Quintet? I thought they were near the side of Andromeda. Let's see. Not there. There's another side here. Yeah, there's Andromeda right there. So I thought Stephan's Quintet was by here. Is this it? Stuff that was near there. Look, oh, wait a minute. Is that it? Now, not enough objects together. But yeah, all these little galaxies everywhere. These are small ones. So you have to zoom in a hell of a lot to really see them. Fast. Yeah, I'll look for it another time, but famous thing called Stephan's Quintet. It's kind of fun. We were able to see, I think, two of the quintet one night. The rest of them are really hard to spot. So, a lot of esoteric stuff here too. Here's North American Nebula. Does look like North America. So, if I turn the orientation just right, there's Florida, there's Mexico, there's California. Baja's kind of broken up a little bit here, and Canada up here. So that's North American Nebula. Very big object. So there's a lot of, around the Summer Triangle, a lot of good stuff. One of my favorites is the Veil. It's a supernova remnant, and it's so big because it's so much energy, and over time it's spread out. It's this huge thing is a supernova remnant. So you get this one part that goes, this little arc. One looks like kind of like a broom, but this whole thing is the Veil Nebula. You can see the general circular structure of it because it's spherically blow out in 3D. And there's this part that's curved like almost like a specular highlight with a curve around a bubble or something like that. You get this kind of an arc. And then this other one, which is kind of twisted going through a star, looks like a broom, like a witch's broom kind of thing. And you can see those really easily in Yosemite with no filters, a nice scope. But you use filters to make it pop a little bit more. And obviously this is long exposure to get all the colors and the shapes and stuff. It's a lot of work, but the Veil is really cool. But you can see how big it is. It's about the size of the full moon. Since I looked at it, but it's a huge area of the sky, and there's all kinds of nebulosity here around the middle of Cygnus here. What's this guy? this the Key Nebula? I don't know that one. And then they're cool clusters too. I gotta show this, and this cracks me up all the time. I find this guy in the scope pretty easily. Speaking of Cassiopeia, way over here. Sorry, this way. And I see if I can dead reckon it without having to browse. And I believe so. On one of the streams, I showed this star. This is a nice double star called Eta Cassiopeia. Is it this one? No, I got it wrong one. Hold on. Oh, what's this guy? Oh, that's beautiful. Oh, the Pac-Man Nebula. It looks kind of like Pac-Man. Distorted Pac-Man. That's funny. Some of these are more modern names, obviously, because Pac-Man didn't exist 100 years ago. What's this? I think it's here. It's an origin yellow binary. No, it's not. I guess that's it. Yeah, that's it right there. So you can see the colors there in the scope. It's really nice. But there's another structure right around here. And I gotta find it because it'll crack up when you see it. I have to look up the number real quick because I forgot. It's another NGC number, but I always forget some of the NGC numbers. Let's see. NGC 457. Okay, here we go. So let's zoom in to find 457. It should be pretty obvious. Dragonfly cluster. That's interesting. So open clusters have little dotted circles. Globular clusters are little crosshairs. Looking for 457. Should be pretty easy to find because it's a pretty major object in the area. And it's down off of... Oh, there's a satellite going by. Is that another Starlink? Nope. OneWeb. Interesting. NGC 457. That's a nice cluster there. Wow. Beautiful. Butterfly cluster. I was hoping to find... That's 664. There's a search feature on here that I haven't used. Somewhere. That's the tools. There's a way I can look up the hotkeys for this stuff so I can get around easier. But it's an IC object. What's this guy? Another IC. Could could have sworn it was right by this one star on the point. I don't know. Once I find it, when I'm observing, 22. I find it all the time once I get it nailed. Salt and pepper cluster. Huh. I've never seen that one before. Screaming skull cluster. Okay, now I gotta look at that one. What the hell is that? I guess it kind of looks like a screaming skull. I don't know what the orientation is on it. I'm seeing, yeah, like eyes and a mouth there, and the skull shape of the head. Screaming skull cluster. That's hilarious. But it's not the one I wanted. I forgot how far away. I know it's in Cassiopeia. There's also like a coat hanger cluster. There's anyway, it's loosely, I think it's not official. It's called the ET cluster. It looks just like ET with two bright eyes, short legs, and these arms reaching out like it's waving to Elliot or something. It's really cool. People crack up every time they see it in the scope, because as soon as you see it, you really see it. But I can't find the cluster. It's not major enough for the software to find it for me. I'll give up on that one. So let me go ahead and, while I'm remembering, switch back to the camera on the phone just for a little bit more fun. On top again and show a few more of the other apps I was thinking about. So that was Stellarium again. Played that for quite a while. That's the one I use for my observing sessions because it's has a lot of cool objects. It tracks well with the telescope software, so I can use the software to drive everything. And while I'm clicking around, you guys can see exactly what I'm doing, so you can learn the sky as well as do that. There's there are a couple other ones, and these also have PC equivalents or Mac equivalents. One's called Celestia. Celestia. And right now it's in a tour mode, it looks like. Jumping around. So again, you can have planetary views. This one actually has a 3D. So this one's combining a planetarium that has 3D navigation, as well as you can see I'm warping around different objects. And it still has the embedded Milky Way matrix. So you can see there's the Earth. And now you can do... Now I've locked it into more of a 2D mode. Then I go back to the 3D mode. You can navigate around things. Zoom in and out with these controls. I forgot how to use the app. It's been a little while since I used it. Here you go. So you can jump around. Center of the Earth, go to the Earth. You can follow things, track things. There should be a browser for here's a quick search. Let's do GC 57. Oops, too many characters there. GC 457. Go. I have to turn the brightness up, I think. Pitch it out a little bit. Not quite getting the orientation that I want. It's kind of cool that it shows star color here, so you can not just see. Rotate, I can't rotate. I think you rotate with this one. Yeah, see here it's cool. See, look at that. I'm actually getting parallax as I put in rotate mode and rotate. You can see how the stars are actually relating to each other with parallax. So that's really cool. A lot of programs don't do that. Go back to 2D mode, and now I'm in 2D. So that's pretty special. I don't think Stellarium does that. Oh, there's an actual object there. What's this? Oh, it's Andromeda Galaxy. So it is next to Andromeda Galaxy. That's hilarious. The whole time I was there. I may go back to that later if I can find it in the bigger software on the desktop. So Stellarium has a lot of cool features too. I'm sorry, Celestia. There's an older series called The Sky, which has been on Mac and PC for decades. I think there were separate programs. The Sky, and there was Redshift, and there were a bunch of stuff. I think they're all the same company now. And so, let me bring that one up. That was one of the old ones. You could actually hook up your pocket PC phone, the old compact iPacs, and all the old Windows Mobile stuff before iPhones came about. And you could actually, so here, this one's also doing the tracking. And unlike the other software, which I couldn't find the turn off thing, you have a mode where it gives you the horizon, but it's also transparent. So while you're going around looking at stuff, and you want to see stuff that's gone below the horizon, it's really cool how it gives you a transparent horizon. You can still see the Milky Way going down here. The objects have already gone down. Some programs don't do that. They either give you horizon, no horizon. But this one's clever because it actually gives you a transparent planet. So you can look down through. So the top of your location is your zenith. And the bottom of your location through the Earth is the nadir. So you can actually look at the nadir through the planet, which is kind of cool. And this also has the constellation drawings, and the ecliptic is here. See, the planets are going on the ecliptic, which is also the zodiac in general. You got embedded images. There's California Nebula, looks like the state of California. I'm getting too much there, and I get some color a little bit to it. It's kind of a reddish pink. Again, the shapes of the constellations. You got a nice running clock at the bottom, the date and time. Some hotkeys over here. There's your little compass showing your angle without having to take a space on the sides. You just have a compass. You have, I don't want to do that. Oh, actually has built-in ads. I don't want that. I guess I got the free version. This. There's North American Nebula again. So all this cool embedded stuff. So even this program that's been around forever, it's updated its game as well. It gives you a nice scene simulation where it's atmospheric haze, Milky Way has a certain quality to it, embedded objects, constellation shapes. Let's see how it holds up with the planets. There's Saturn. Okay, so in this case I can't. This program is not that clever. It's good in its own way. That's why I'm showing you different ones. Saturn I can choose and I can zoom in, but in order to see any more about Saturn I have to go in here. And it will give me all kinds of texts. I can look at the... So it shows you the angle of the rings. It's kind of cool. Gives you little quick measurements. There's a picture of Saturn. There's got to be a way to show the moons here. I've done it before, I thought. That's centering it. Oh. Okay, that's not cool. It's now giving me ads again. Hey, but I think it was free. This is the free version. I didn't pay for this one. I paid for one a long time ago on the Pocket PC. And this was one of the first apps to actually have telescope control from your mobile device. So again, they were ahead of their time. Can that zoom in? I cannot zoom in. How do I show? You can mark it as a favorite. Okay, there we go. You hit the telescope button and it zooms in. So it's not... Oh, no, okay, there we go. I just had to toggle it. There is a way to look at it along with the other stuff. Oh, no, it's a 3D mode. So this is giving you an orrery. You're actually getting a... Zoom out, you can actually see the other planets around it, looks like. Oh, maybe not. It's just a different kind of view. Ads again, see? You guys shouldn't do this. You're making yourselves look bad. Okay, I see what it is. It looks like a rocket ship. So it's changing your database. Right now we're kind of in a 3D navigation view, and you can pinch and you can see. But the cool thing about this, unlike the other programs that are flat, you're actually getting a 3D representation. Not just seeing where the moons are in the line, but you're actually able to warp around Saturn and see exactly where the moons are. Which is, there you go, it's got an advantage now. So when you're not in that mode, let's go back to this view. Yeah, that's pretty cool. What does that view do? Stop giving me ads. They're probably going to get me to buy it though, because I do like having that. The feature's actually pretty cool. Let me do this. Let me go. How do we get away from this? Today's sky. So it shows you what's coming and going. What's visible, what's not visible. I can go. Sky scanner. Ah, you ads. Don't do that, man. Sky scanner. Oh. So it's giving me some kind of like pointer thingy. It's interesting. Intro to Astronomy, they have like some little tutorial stuff in here. So if we learn about the sun, give you some facts and figures about the sun. Yeah, see, About the Sky by Redshift, so that they merged, the companies did merge. Upgrade to premium version, there you go, so I can get rid of the ads if I do that. I might do that because it's actually a pretty cool app. It used to be more diagrammatic, like you didn't have simulations of Milky Way and stuff. You just had constellation lines, basic symbols for all the deep sky objects, names, shapes, outlines maybe of where a nebula would be, but no drawings and no photographs and all that kind of stuff. It's a pretty primitive app as far as the appearance, but the information was great and it was really easy to use. And at the time, it was only one of the few things you could carry around in your pocket. Let's see, what's that? Whoa. That's cool. Whoa. That's like a little rocket ship mode. I can fly all over the place. So you can do like simulations and animations and stupid ads. Get out of there. So that's fun. So they took elements of that skywalk, starwalk thing I showed you before, and built it into a proper planetarium app that has all kinds of tech information as well. It probably still has scope control too. So I like that. That's the sky by Redshift. So you've seen Stellarium, which is the one I use all the time. Celestia, which is a slightly different version. It had some of that 3D navigation stuff. It was cool. The sky has some of that too now, which is good. And then another one I upgraded to recently, which is really deep, called Sky Safari Pro. And this, in general, this is one of the most elaborate ones I've tried so far. Oh, before I forget, I totally bypassed this. There's a funny thing that's powered by Unity called Our Galaxy. And you can actually rotate Milky Way. And look what it's showing. All those yellow dots, like I was saying before, those are all globular clusters. Showing how they're in the halo, the outer rim, and the bulge of the galaxy. So you click on one. I'll tell you which one it is. And it's cool because it's, you know, it's oriented, so they know where it is in relation to the rest of the galaxy based on all the measurements they've done. So you're getting a 3D representation of globular cluster distribution. It's really nice. So as you can see, it's taken me a lot of different apps to get all this information. Not one app does it all. Not even two apps do it all. You need a handful of apps to really get all this cool information in one device. Definitely can't do it with one app. Looks like there's some other stuff here I'm not going to play with right now because it's a small interface. I got to figure it out. But that one's really fun because I believe this one was also free. It's called Our Galaxy. So that was good. And let's go to Sky Safari Pro. That's what I was talking about for a while. There you go. Sky Safari Pro. So again, your standard, got the constellations, got sky simulations, so there's some Milky Way, you know, and you can zoom way in, and as you zoom in, you're losing the effect of the atmosphere, the sky glow kind of stuff, because just like when you look at an eyepiece, higher power, it gets darker and darker and darker. So it's simulating that, which is cool. There's telescope control here as well. A little button for that. There's a observing list. So if you want to look, there's a planner, so you can actually plan your evening's events. Restrict various settings, and it'll basically help you plan an observing session. There is events coming up. So here you go. Shadow, that's one reason I got this program and updated it. All the shadow transits. So Io shadow transit. And not only can you talk about it and see that's going to happen, but you can simulate it. Look, there's playback here. Check this out. There's Io. There's the planet. So before you even watch the event, you can simulate the whole thing. There goes the thing. Watch the shadow go across. Sometimes the shadow's a little, yeah, you saw it, it was very small. zoom in a little bit. So what I can do is I can actually go back to the actual Ganymede shadow transit I saw several months ago. Start date, I think it was NAM was in April, I think. I had this little thing you keep seeing in here. This is a zoom feature for when the app has just tiny text, and you can just double click it, choose a zoom, and kind of navigate around the screen. It's actually really handy, but it does get in the way sometimes. So let's see, June, I think it was April, wasn't it? Let's just see. So, should be a Ganymede shadow transit. There you go. Now it's in slow. Play it backward. Whoa, what happened there? Ganymede shadow transit. So you can find, so there's Ganymede right on the edge of the planet. Oh, I should turn this down, but it's too bright for the camera. There's Ganymede. There's the shadow just taking a bite out of the disk. So if I do this, well, damn it, I zoomed in too much. Backward. Zoom in and go over here. There's, yeah, you can see the shadow, and there's the Ganymede right there. That's so cool. Play it backward. There it is. It's entered. It's going across. Oh, it's zoomed in too much. There's got to be a way to, so it doesn't keep trying to center the planet. I want to see the edge of the planet. Probably just have to, I can't rotate it. But you get the idea though. You go back and forth and there's the shadow transit. That's what I saw basically back in April up at Yosemite. It's really cool. So depending on what moon it is and what time, what the angle is and stuff, sometimes you see the shadow leave first and then the moon leaves, or if the moon is, you know, way out here but the sun is hitting at a certain angle, then the moon leaves first and then the shadow leaves. It's really cool, but this app is great, man. This does so much stuff. So those are your shadow transits and other events. You can look up all kinds of stuff. You can log your observing sessions. You can pick observing sites and database. Scope display. You can simulate the parameters of your scope. So not only does your telescope track with the software, but you can also get the view of your telescope in here, and viewing matches the specs of your telescope. So scope presets. You can track your own equipment in here. It's like a database. Again, there's a telescope. There's a search feature. So like tonight's. Here's all the good stuff to look at tonight. So there's some satellites that we missed. What's coming up next? Cat's Eye Nebula. So we can say, how do I, yeah, some of the features on it I don't know, but it's showing you things that are visible, and so Vega is just a star in Lyra, but you know, I've already seen that, but it'll give you some information on it. Apparently it's doing something interesting. star cluster there, M71. Dumbbell Nebula, that's what I was trying to show you earlier. In Cygnus by Sagitta. And let's go. So they'll check all this stuff. They'll check apparent motion, coordinates, physical parameters. It's really, really nerdy. As nerdy as you want to get with some of this astronomy stuff. There's the typical scope view of it, but really bright. So this is an exposure, but black and white. So just imagine a hell of a lot dimmer and softer. That's what it looks like in the scope, pretty much. So you can learn about all this stuff pretty easily. What does this say? Center. Okay, now it's going to center the object, and I can see why I went wrong. Turn on the, just so you guys can see where it is. Let me turn on the, so this also has night mode. Is it really a night mode? You can turn on, there's some other syncing stuff, One Sky and Sky. Oh, there's a Sky sharing program here, so if you're using this program with your friends, you can show what you're looking at. And if they have it also turned on, they can see what you're looking at. So your buddies can log on and say, oh, you're looking at that now? I'm going to go look at that. And you can talk to them online or call them or whatever. It's kind of a fun thing. You can do that. You also share. There's a share feature to share images or share data. There's a help feature. There's, here we go, settings. Let's show the coordinates. Notifications. Deep sky objects are on. Milky Way constellations, here we go. Show constellations. So you can, like, if you just want to see the zodiac, you just have the zodiac on only. All the other ones will be no lines for those guys. Well, constellations are turned on. I guess they're just it's a focused view, I guess. Yeah, they're there. They're just faint lines. You can turn the brightness of the lines up. So where was I? I was looking at Dumbbell Nebula. Let me go back to search. Tonight's best. So I'll show you tonight's best objects. And I think I already found it in this list. Helix Nebula, that's a really cool one. Well, let me just do this instead. I'm going to do M27. There it is. I'm going to center it. There it is. Oh, it's in Vulpecula. These are all, see, 21 vol. All this is the star numbers with the Vulpecula. I thought it was in Cygnus for some reason. So there is, okay, there's Sagitta. Okay, so it's between, there's Deneb, so there's the Northern Cross, and the Swan. There's Sagitta. Okay, so it's up. I was going over to the side. It's up from Sagitta. And into Vulpecula. And again, it's embedded in the matrix. Just keep zooming and zooming and zooming. And there's a shot of it there. It's going to be washed out in here. There you go. You get the, it's got hourglass shape. It's more of the Hourglass Nebula than the Dumbbell Nebula, but it's a decent name. There's also a little Dumbbell Nebula, and I think there's one called the Barbell Nebula. It's kind of funny, but I might be misremembering that. Anyway, so that's. Turn the brightness back up again. So yeah, if you just do a quick browse, some apps obviously weren't that easy to search in. This one's even easy to search in, even though it's a complex app. So I like this one a lot. Sky Safari Pro is quite nice. I haven't tried the telescope control with this or even Stellarium on the mobile apps, but they do offer it. I'm having so much luck with my laptop, I just keep using the laptop. But if I really had to and I want to be even more mobile, I would just do it all from the phone and make less stuff to carry, less batteries to charge, all that kind of stuff. But yeah, look at the beautiful Milky Way stuff. It's all the dust lanes in there. And see, I'm at the zenith now. It even says zenith in orange. So if I pull all the way back, and look at that, Andromeda is at the zenith, which means it would be the best time to look at it right now. Look into the thinnest amount of atmosphere. And see, this one's nice because in some of the views, you would click on Andromeda in the matrix and zoom in, it would only show you M31 and M32. But because this is a fully integrated thing, you don't see like cutouts of the those weird like squares and stuff. NGC 205 is there too. I can go browse. NGC 205. So I meant to click on something wrong. What's going on? There you go. Well, they're calling it Messier 110 here. But it's the same thing. It was NGC 205 long before it was Messier 110. So again, amazing, detailed apps. Turn the stars off, constellation mode or shapes, and there's also constellation boundaries where they put like grids across all the constellations. So when you want to know where the constellation officially is for the object you're looking at, the boundary will tell you as well as the name, like when they name the stars and stuff like I showed you there. And then Jupiter. So here I can just keep zooming on Jupiter, and there are my moons. Now there's no 3D mode as far as I know, like there is on that Celestia. That was pretty cool. But it's what's this doing? That's observation list. And what does this do? This is just tonight's stuff. So yeah, you click the tonight button, and look at that. You get a nice little view graphically of all the stuff that was going on. You know, rise and set times for the moon, phases. Nice shots of, well, it's even got light pollution maps. So it knows where I am. Look at the light pollution maps. So if you're curious, go expand this one here. Let's see real quick. Okay, well, the light pollution map is pretty cool. It's another premium feature. And I think I'm going to have to get it. Let me see here. So, oh, I see what they're doing. Start with free trial. You know, maybe I'll wait a little bit. I don't want to have subscription services on too many things, but it is a cool feature if I wanted it. You can see it's an option. It's $30 a year to add the light pollution module to it. I'm not that crazy right now, but it is kind of fun that they have that. That would normally be another app, and it would, who knows how much that would cost. But there's in a nutshell, I can quickly see though. I can use my little zoom feature since I didn't pay for the thing, and it'll show me. I'm currently in Mountain View, and I'm in a bad area for light pollution. It's red. But see, if I go up here to the foothills, or if I go even further out to Pescadero, or closer to this section of the coastline here. So if I go out to the coastline, it's more of a green or dark green. And if I go to, well, I don't even have to use the light pollution map to show you Yosemite. You just look at the Earth at night pictures, those mosaics of the Earth at night, and you can clearly see Yosemite, and quite a way around it is completely black at night. There's no light pollution at all. Other stuff coming up later. We're talking about the full moon. We're talking about some solar system objects here. So you can see, talking about shadow transits of the moons. Deep sky. Let's see about the Helix Nebula. It's probably in a good opportunity position, probably closer to zenith or something like that. But yeah, there's the idea. You get lots of information in one app, but again, one app can't do it all. And because some of these guys, I didn't even show you some of the apps that were all subscriptions. Some of them you fire it up thinking it's going to be cool, and they literally want a subscription right off the bat just to do anything. I said, yeah, that's not my thing. I like to add stuff occasionally with a subscription if it's that cool, but I don't want to just subscribe and be paying constantly to use an app. So far, the updates I did to this app were just one-time updates to add a database, like more Hubble information or something like that. Or I added more Hubble information to that exoplanet app, so it could do all that galaxy, 3D galaxy comparison stuff. That was really cool. That was totally worth it. But time-based subscriptions, where it's like a month or a yearly thing, and then if I don't use it for a while, then I just spend money on nothing. So that's pretty much it for the apps that I found. And I went on much longer than I had planned, but I am having fun here. So hopefully you guys did enjoy this, as nerdy as it is. Hello Hayes, how's it going? Been going on for quite a while here. I lose track of time pretty quickly with this stuff. How long has this been going on? Check my feedback here. Why is this stuck now? There we go. Wow. Going for 4 hours? Holy moly. Get me talking sometimes, and I'll just keep talking and talking and talking. But these apps are a lot of fun. There's a lot of power here. Plus I did some tutorial stuff for showing people how to find stuff in the night sky. Stuff to use like red acetate and camera adapters and lasers. Other kinds of fun stuff to make your experience more enjoyable, more interactive. And as I was showing on my first test stream with the new, not the new telescope, not the stuff I did like 6 months ago, it was crappy spotting scope stuff. You can basically do, if you attach an iPhone to your telescope mount, whatever, with this thing, you can do some pretty amazing images. If you use the right apps and dial in all the settings and stuff. Using the basic Apple app for photo doesn't work that well. It's okay, but you want to have total control over the exposure and manual focus and all that kind of stuff. You don't want to be messing around with auto anything. So that's the deal with that. I think I showed you all the other apps I had planned to show. Some camera apps. Weather apps and planet and moon map kind of stuff. And again, there are other ones I could show, but a lot of them are kind of overlaps with the same stuff I showed in these other apps, especially the stuff toward the end. These kind of monolithic apps that do a lot of stuff. Just massive user settings. You can import your own data as you find out about new stuff, like you know, the Stellarium and some other stuff. You can add the exoplanets. Now you're not going to see them, but because it's a planetarium software too, and you just want to sit in your chair sometime home and just play with the universe, you can actually look at where they are in the night sky and just imagine you can see them. One day they'll be able to, you know, have higher power devices that could maybe image them, and not just have them there from esoteric data collection. So, and you know, Stellarium was basically free, I think, if I remember correctly. I'm not sure if I can't remember if the mobile app was. At least the basic features were, but here the desktop app was free. Let me go back to OBS here for a second and toggle my view. Let's put Stellarium back on top. And like I said, you can do zoomed way in there. So they've got, again, this quick menu down here. Just roll across and you can toggle things off really quickly as you feel like it. Pulsars, quasars, deep sky objects, satellites, time-based stuff, night vision, red eye, red light stuff. Go in full screen and out. So these are, you know, toggling various modes. This is the, as I was showing before, the constellation stuff. Turn the constellations on and off, the names on and off, shapes on and off, so you can learn why the hell they're shaped the way they are. Constellation art, turn that off. You turn on grids. So if you want to learn more about more detailed stuff about which sector something is in. So this is an azimuth grid, so if you're using alt-azimuth telescopes, this is more appropriate for those kind of uses. So this is equatorial coordinates for a German equatorial telescope. This is alt-azimuth for alt-azimuth style scopes. So it helps people who are using either one. This is what's this again? Oh, here's the ground. Cool. I missed that earlier. Yeah, that's nice to know. So you have atmospheric functions, or just turn it off and you get, oh lovely, it crashed again. It's that same bug where you have it in a window mode and it thinks I clicked close when I didn't. Let me fire it up one more time. This silly program. Silly program. Are you gonna launch or are you not gonna launch? What's going on? Alright, now it's popping up. Well, it was popping up. There you go. Now it's open. I'll go back to window mode because I don't like the full screen. I want to see what I'm doing. Hopefully they fix that bug that's making it do that. So now I can go over here and it opened multiple versions of the app. That's silly. Come on, don't do that. I got 2 versions of the app open. That's hilarious. Okay, now we're back to window mode. Looks okay on the stream. It's not weird. Change the size of the window. It's a little bit easier to navigate. Okay. Now we're back to normal. So down in the interface here, you can actually hide the ground. So now you got the entire sky. They still keep the horizon line with the compass headings, which is nice. And you can see the moon is just about to ready to go down. It's about to set. But it's fun because you can go in here and learn about some constellations you'll never see unless you travel. So I'll turn these back on. And here's microscopium. So here's Pavo the peacock, octant. So this is what I was talking about before. See how this is rotating kind of around this area? There's no true south pole star, like we have Polaris for North Pole star. There's no true south pole star, so there's a star in octants called Sigma Octantis. It's the closest they got to south pole star. So you would align your scope to that if you're down there using polar alignment stuff. But you have, so here's all the Carina, Volans, Vela, Puppis, Pixis, Antlia. This is the Argo Navis. It's the Argonauts ship. It used to be one giant constellation. They broke it up into a bunch of different ones. So now you can see Ursa Major has shifted around. This is the Big Dipper, Big Bear. It's now, below the horizon and shifting around like the hands of a clock. And sun is down here. Here's Leo. Leo, Virgo, and stuff. There's a lot of great galaxies in here in the spring. So I can't wait to start looking at this stuff. It's just below the horizon this time of night. But here's Virgo. If I zoom in here, you'll see an insane amount of stuff starting to pop out. If I turn on the deep sky, deep sky is already on, looks like. Yeah, it's already on. And you get these clusters. favorites is Sombrero Galaxy here. Look at this guy. This is one of the few, like Andromeda, this is one of the few that looks like it's in the scope as it is in pictures. There's the Sombrero Galaxy. You see the nice dust lane going through it? It makes it look like a little hat. It's beautiful. Love the Sombrero Galaxy. So M104. I have to zoom out to actually click on it. There you go. Also called the Dark Lane Galaxy. Just all kinds of cool stuff in there. See, look at all the stuff that popped out. There's a Vinyl LP Galaxy. Okay, these guys are reaching now. What does this one look like if I can zoom in on it? Oh, it's too fast. There's not. They don't have an image of it. It's so. It's such a nothing. Magnitude. Wow, no wonder. Anything above 10th magnitude, unless it's Pluto or something like that, is really hard to get a view of. It's super faint. Because galaxies are already contrast challenged anyway. So what's this? Another one I really like, which is I think already set by now. It's a southern object, but we barely get it from here. It's called, it's a galaxy in Sculptor. And let me turn the land back on. And there's Phoenix, here's Sculptor. Here we go. So it's low on the horizon, but from Yosemite it's quite nice. But you actually have to go, I think it's this one here. No, it's not that. It's even lower, I think. I think it's one of these guys. It's not that. It can't be that low. No, it's not. That's the wrong number. 7410. Is it this one? No. Maybe it's this one. No, it's not in Groose. I thought it was in Sculptor. It's NGC 253 or something like that. I forgot. Take a quick look here. I'm going to see if I can find it. I can look up the number. NGC. Well, it's just like it's just called the Sculptor Galaxy because it's pretty unique. NGC 235. No, wait. Yeah, 253. That's right. So I was right. Just had to verify. So now we do a search on here. This app is not as. Oh, there we go. Oh, it's up there. It's called the Sculptor Galaxy. So it is higher than... I always thought it was lower in the horizon. But that's true. Yosemite is lower than we are. I'm in a local setup, so... Oh, just lost my bounty. And let it go. Just get a double open again. Oh no. I clicked something wrong again and it crashed. Give me a minute. You gotta see Sculptor Galaxy, it's pretty special. Or you know what, maybe let's just switch back to the camera. You've already seen it on the desktop. Let me, it's giving me a headache, that stupid bug. Keep that one on top. Yeah, you can open in the background. I don't care right now. Just leave you in the background. I'll show you on the app. GC253. Look at that. That's a beautiful. It's really impressive in a scope because it's huge. Let's actually get some color in this image. Let me drop down the brightness again. So again, it's like a giant cigar. It's an edge-on spiral, or almost edge-on spiral. A little more tilt, I think, than Andromeda has. But it should show where it is. No, there we go. There it is in the matrix. So Sculptor is... yeah, there's Cetus the whale. So it's below Cetus and just above Sculptor, or part of Sculptor. Turn the brightness up again in the app. And this is a different exposure of it. It's a little more blue here. Big, beautiful thing, though. You can see from here the scale. You want to zoom out, you can barely see it, but you can see the constellations nearby. It's massive. I think it might even be bigger, not bigger, maybe about the same size as Andromeda. Almost the same size as Andromeda in the sky. Just stunning. So, anyway, went on way too long, but hopefully you guys that are into this found it enlightening and interesting and all that good stuff. Obviously I had fun doing it because I wouldn't shut up and just kept going. But again, don't forget the lock screen. Shows you the Earth with the current cloud patterns, which is very handy for choosing to go out and look at stuff. And don't forget to, if you feel so inclined, leave some comments in the uploaded video. Had some decent chat earlier in the stream, but I know it's a weird time for part of the world, so people probably watch it on catch up. But anytime you guys come by, I really appreciate it, because I'm going to do this anyway because I enjoy it, but as you can see, I got carried away. It's like a 4-hour stream, probably longer. This is becoming a pub show, kind of, sort of, long format. But as usual, I appreciate everyone joining in and making comments and like I said, the engagement is a big part of the fun of this thing, just like it is in real life with a star party. And we show the public stuff and they ask questions and we say, oh yeah, we'll check this out. And like, whoa, you know, it's all very rewarding. Tiring too, because they're long hours and a lot of standing, a lot of squatting, a lot of bending over equipment and stuff. But when you're motivated, it's a lot of fun. People get excited. It's nice to see people care about science and care about the environment and care about something other than social media and TV shows and movies. So, but yeah, thanks again, everybody, who did come by. Thanks to anybody who watches later. And again, like I said, make comments in the comments section. Ask questions, make requests if you want, whatever. As these are interactive, and I'm not just sitting here presenting a bunch of canned material. It's dynamic, so people can say, well, what about this? Can I look at this? Can I look at that? And I'll do a better job of watching the chat. So if you do ask questions or want to see something, I can do that. And even at the scope, you know, this is all simulated stuff on the computer, tools and all that, but I can do the same thing at the scope. You know, if I'm in a certain area of the sky and I can ask if someone wants to see something in a certain constellation, if they know it, or just throw out a random object they may know, and if it's available and it's not too far away from where I am and it's above the horizon, we can take a look at it. It's just it's part of the star party mentality. So, but yeah, definitely, you know, hopefully some of the stuff I said earlier helps with going out, using the apps to find stuff in the sky, because it tracks with your GPS and your accelerometer and stuff, tilt sensor, so it knows exactly where you're aiming the phone. And it's so easy now to learn the sky with just a couple of apps. You know, I was a kid, I had to do this all manually with a little planisphere thing. It's like a little, like one of the programs I showed where it's little setting circles, and you can dial in your thing, and you had to buy it for your latitude because it's only good for certain latitudes. You dial in the time of night and the date, and it would kind of roughly give you an idea what you're looking at. So if you're not sure what constellations are up, it narrows the search a little bit, so you can see what's supposed to be there and just match the star patterns, and eventually learn the shapes and learn the mythology behind them and the cool objects that are in there. And eventually, if you're really into it, learn to star hop. You learn some of the really cool objects off of some really major stars in the constellation, and learn how to star hop by matching, you know, triangulating coordinates visually from one area of the constellation to the other. And sometimes it's like, you know, M27, the Ring Nebula in Lyra. It's so easy to find because the constellation is very bright and present all night in the summer. And I think it just set like an hour or two ago, something like that. Maybe an hour ago. But it's the object in question is literally between two of the very bright stars in the constellation, and you just find one of those stars on the way to the other one, almost to not quite center, but maybe 60% of the way over. The thing is right there, you can't miss it. You can't even find it in binoculars in a good sky. So you have some of these things are very easy to find, and as you get your confidence up and you learn the stuff and you find you like it even more and more and more, you can memorize various parts of the sky and just star hop. One of the friends in my club a long time ago, when I was still a real beginner, had a really good book on Starhopper's Guide to the Messier Objects. So it had basically all the Messier objects with constellations drawn and then little arrows. Just like if you get like a Peterson's Field Guide for birds, and he puts little arrows next to, look for this marking next to the bill, look for this feather pattern on the head, look for this marking on the wing, you know, all these little details that you look for that immediately tell you diagnostically this is what you're looking at. It's a similar thing to star hop. You just look for key stars and key orientation, you know, ways of looking at where the thing is in the grand scheme of things. And pretty soon you just go boom, 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 boom. Don't need a chart. Don't need a computer. Don't need anything. So when you do eventually get a computerized system, if you're really into this stuff and just want to make it a little bit easier on yourself, you really appreciate how much time it saves you, because it just goes finds the stuff for you. And if in a given time it doesn't find something for you, you know where the thing is. You can correct the software. You can correct the drive with your little hand controller or the software you're hooked it up to, and reorient yourself without having the computer messed you up and now you're stuck. So it's very powerful skill to have when you're doing stuff like that, especially when you're doing a star party and you know someone's really impatient, like, oh, I want to see this thing, I'm not going to wait all day, and so hold on, let me find it, and they're like, all right, I'm going to go look somewhere else. So the more accurate you are and the more you know the stuff to jump to without waiting for a long time to a motor to slew one direction or the other, or to correct the errors that the computer had over time of using the scope for the night. You just know how to find it yourself. You don't need somebody else or some other tech. So this guy's book is really helpful, and I just started coming up with my own versions of the same idea of finding the certain stars to look for and go from there. And it's really, really handy. Of course, if you don't do this every year, or at least every 6 months or something like that, you really start to forget some of these little key details. So you can take notes, or you can go find a book that has it for you. You just reference the book. It actually helps a lot. And he had a really nice scope. It was a kind of a homemade type scope made by a small company called Sculptor Optical, and it was the first portable giant scope that I had seen. It was a 13-inch diameter Newtonian reflector scope in a big red tube, and I was like, it's called the Sculptor Odyssey. I'm like, wow, where'd you get that thing? Is this some, back of a Sky and Telescope magazine or Astronomy magazine? The Orion telescopes didn't have all the fancy scopes they have now that you could just buy easily. You had to either go to some research grade place to get really expensive scopes, or buy one of these mom and pop kind of place scopes, or go to a telescope making class, grind your own mirror, and make your own damn scope. They still do that in a lot of science museums and stuff around here. So this guy bought this system, and at the time it seemed like a lot, but then I saw what you could do with the scope and how easy it was to use, and it was only like, I don't know, $1,500. And then 10 years later, I'm buying a similar scope for only $1,000 with some computer components. Even though it didn't have a motor, it still had a computer, so once you calibrated it, you could use it as a manual go-to. So that guy showed me a lot of cool stuff between the book that he had and the scope that he bought me. He also fit the damn thing inside of his BMW. He was able to put the front seat all the way forward and wedge the giant telescope in his car, and then put the mount in the trunk, this Dobsonian Lazy Susan kind of mount, alt azimuth. And he just drove up to the site and set it up. I'm like, wow, this is so cool. So, nice guy. And it was a long time ago, and he was quite a bit older than me, so I'm not even sure if he's alive anymore, but his name was Ken Mapes, I think. He's a really nice guy. Haven't seen him forever, so who knows what happened. So yeah, another thing that's good about going to these events is you talk to various people, you see different approaches, you learn about different equipment and how to use things differently, the cost of things, the whole works. It's really impressive stuff. Saves you money, teaches you some stuff, and it gives you an idea of what you want to buy, when you want to buy it, if you want to buy it. Some people aren't into this stuff, they don't want to buy anything, but it's just all these options you have. So, but I'm exhausted, so I'm going to call it quits and end the stream. So thanks again to everybody who came. Like I said, leave comments, questions, requests. Stay tuned for next time. I'm not going to have it as long next time because I think I talked enough for 3 or 4 streams right now. So, but definitely, if you're on the fence about using iOS or Android or iPads or whatever for this stuff, you've seen the software is amazing. It's a planetarium in your pocket, and with connecting cables and stuff, you have scope control. You have 3D rotation software showing how galaxies are oriented. Even that one program even showed you how the damn moons are around Saturn and Jupiter in 3D. That's the first time I've seen that in a program like that. That wasn't just a dedicated 3D simulation program. So yeah, so I learned some stuff tonight too. It's part of the fun of doing this stuff is I'll try something I haven't tried before just to make it interesting, and I'll learn some things as well. So yep, that's it. I'm gonna stop before I go too crazy. Too much stuff, and I need some sleep. So thanks again, guys, and stay tuned. Keep watching the skies. Watch out for UAPs and UFOs, and as the Star Hustler said on the famous program that was on public television from the Miami Space Transit Planetarium, and it played the Debussy music from Snowflakes Are Dancing. Hilarious, the great electronic versions of Debussy that Tomita played. It was one of their theme songs for the show. At the end, he goes, "Hello, stargazers. Remember to keep looking up." So, funny old guy. But he had a fun little show. So, thanks again, guys, and I'll catch you later.